The ground itself is breathing smoke. Somewhere across the northern half of the only continent, a wound in the crust the size of a country will not close. Fissures open across what is now Siberia, and dark lava sheets crawl outward for hundreds of miles. The air tastes of sulphur and hot metal. Stand here on this stony rise and the heat presses on your skin like the open door of an oven. There are no dinosaurs anywhere on Earth. There will be none for millions of years. This is the end of the Permian, roughly 252 million years ago, and you are standing at the bottom of the worst catastrophe life has ever endured. The sky is the colour of old bruises. Fine ash sifts down and gathers in the creases of dead riverbeds. Out beyond the horizon, in seas you cannot see from here, something staggering is happening. Up to roughly 90% of all marine animal species are vanishing. Not fading gradually, disappearing, family by family, from a warming, souring, suffocating ocean. Let that number settle for a moment. 9 in 10. This is the most severe extinction of the entire Phanerozoic, a long eon of visible animal life. Nothing before it and nothing after it comes close. Later people would give it a blunt and honest name, the Great Dying. Come and walk with me through this ruined world, traveller. Keep your footing on the warm ash and follow the dead river. I want to show you how a planet dies almost completely, and then, against every reasonable expectation, learns to live again. Because this emptiness is where our whole tale begins. The first dinosaurs are not here yet. They cannot be. The world that will make them has not finished breaking. Look at the land around you. It is not a landscape of monsters. It is a landscape of absence. The great forests of tree ferns and seed plants that once covered these basins are gone or going. In their place, bare mudflats crack under a merciless sun. Fungi bloom in the rotting remains of the old woods, so abundant that their spores form dark bands in the rock, a smear of decay you could hold in your palm. Where there were choruses, there is a low wind. Where there were herds, there are scattered bones. To understand how this happened, you have to look back at those fissures in Siberia. Geologists call the feature they left behind the Siberian traps one of the largest outpourings of lava the planet has ever recorded. This is no single eruption. It is a slow, grinding volcanic assault that unfolds across many thousands of years, and it is the leading suspect for the killing that surrounds you. The lava is not the murderer, though, not directly. Almost nothing here dies from touching molten rock. The true weapon is invisible, and it comes out of the ground as gas. As the eruptions tear through ancient coal beds and salt and limestone, they belch enormous volumes of carbon dioxide into the air. And carbon dioxide, patient and colourless, does one reliable thing. It traps heat. So the world warms, not by a few degrees, by a brutal, ecosystem-shattering amount. Watch how the chain unfolds, one link pulling the next. First the volcanism, then the heat, climbing until shallow seas turn bathwater warm and then hostile. Warm water holds less oxygen than cool water, and so the oceans begin to suffocate from within. Vast stretches of seafloor go anoxic, meaning starved of oxygen entirely. In those dead zones, almost nothing can breathe, and there is a second poison working alongside the first. As all that carbon dioxide dissolves into the sea, it turns the water more acidic. For animals that build shells and skeletons out of calcium carbonate, this is a quiet disaster. Corals, certain shellfish, the reef builders that once framed whole underwater cities, find the very chemistry of the water working against their bodies. Acidification and anoxia together become a pincer. Heat drives both. Volcanism drives the heat. That is the causal spine of the Great Dying as the rocks record it. Eruptions to warming, warming to a suffocating and souring ocean, and from that ruined sea a collapse that reaches up through every food web at once. On land, the losses are harder to count but no less severe. The forests thin, The specialized plant eaters that depended on them starve. The predators that hunted those plant eaters follow soon after. An ecosystem is a tower of dependencies, and here the lower floors are being knocked out. Stand still and feel how strange the silence is. This is a planet nearly emptied of its own variety. And here is the honest question that will pull us forward through everything that follows. How does life climb back from a place this close to zero? When 90% of ocean species are simply gone, when the land is a patchwork of the desperate few, what does recovery even look like? And how long does it truly take? Hold on to that question, because the answer is stranger and slower than you might expect, and it splits in two. There is a difference between two kinds of coming back, and paleontologists take that difference seriously. The first is taxonomic recovery. That simply means the number of different species climbing again as survivors branch and multiply into new forms. You can count it like heads at a gate. The second is ecological recovery, and it is a deeper thing entirely. It means the full machinery of an ecosystem knitting itself back together. Big predators at the top, tiers of plant eaters beneath them, complex food webs with many redundant strands, so that losing one thread does not unravel the whole cloth. The unsettling truth written in the rocks is that these two recoveries do not move in step. Species counts can rebound while the deeper structure stays broken. For a long time after the extinction, ecosystems remain what researchers describe as top-heavy and unstable, fragile, prone to wobbling and collapsing again when conditions turn. The full rebuilding of that top-down structure, with stable large predators anchoring rich and layered communities, was still underway in the latest Triassic. That is roughly 50 million years after the dying. 50 million years to truly heal. Let that scale sink into your bones. If you could stand at the moment of the extinction and watch the calendar spin, whole lineages would rise and fall before the world felt genuinely whole again. This is not a wound that closes in a season. It is the great slow convalescence of an entire planet, and everything in our tale, every small hunter, and every marginal survivor is born into some stage of that long healing. Follow or subscribe wherever you are listening, on Spotify, on YouTube, or in your podcast app of choice. It costs you nothing, and it lets these quiet walks through deep time keep finding the people who need them. Now come forward with me, out of the worst of the dying and into its immediate aftermath. Cross the threshold into the earliest Triassic. The eruptions have not fully quieted, and the climate is still lurching, but the mass killing has passed its peak. What remains is a world scoured strangely bare. Ecologists have a phrase for these post-catastrophe communities. They call them disaster ecosystems, and once you have seen one, you never quite forget it. Picture the floodplain ahead of you. Wide, flat, braided with shallow river channels that wander and split across the mud. Beyond the green ribbons that hug the water, the land runs dry and reddish into the hazy distance. There are no polar ice caps anywhere on this planet. The interior of the great supercontinent bakes under a hot seasonal sky. This is a landscape of harsh contrast, thin corridors of life along the rivers, and parched red beds stretching away on either side. And here is what makes it a disaster ecosystem. The detail that would stop you cold if you could stand in it. The emptiness is not total. It is worse than empty in a way. It is monotonous. Where a healthy world offers you dozens of animals sharing the view, this one offers you, again and again, the same face. That is the loop I want to leave open as we walk here, the one the survivors themselves will answer. What kind of animal thrives when almost everything else has died? What does the winner of an apocalypse actually look like? Not a monster, it turns out. Something far humbler, and in its own way far stranger, than any monster. Feel the world these first survivors move through. The sun overhead is hard and white. The mud along the channels dries into curling plates that crunch and shift underfoot. There is water, but it comes and goes with violent seasons, flooding brown and fast in the wet months and shrinking to warm, still pools in the dry ones. Ferns fringe the banks in low green thickets, some of the earliest plants to recolonize a stripped world, tough and quick and forgiving. Beyond them the ground is often bare. Listen, and the soundscape is thin. No birdsong, of course, for the birds are a chapter of the tale still more than 150 million years away. No insect chorus of the richness you might imagine, mostly wind and water and the occasional dull movement of bodies through the reeds. This is what a convalescent planet sounds like. Sparse, patient, waiting. And it is worth being honest with you about how much of this scene we can actually know and how much we carefully infer. The climate patterns come from the chemistry of ancient rocks and the shapes of fossil soils. The plant cover comes from spores and rare leaf impressions. The animals come from bones, and bones alone tell you only so much about behaviour. So when I describe a herd moving across a floodplain, understand that it is a reconstruction, built from evidence and reasoned inference, not a photograph. Scientists argue about the details, and they should. The uncertainty is part of the honesty, but some things the rocks state plainly, and one of them is astonishing. In certain layers of stone laid down in this earliest Triassic world, in what is now the Karoo Basin of South Africa, a single kind of animal accounts for an estimated 73% of the vertebrate fossils. 73 out of every 100 backboned creatures preserved. And in some individual assemblages the figure climbs higher still toward a staggering 95%. Nearly every animal you would meet, one and the same. Think about how alien that is. A healthy modern ecosystem spreads its abundance across many species so that no single one crowds out the view. Here, one genus fills nearly the whole frame. That is the signature of a disaster taxon. A survivor so well suited to the ruined conditions that it floods into every emptied niche at once, multiplying across a continent while the competition lies in the rocks below it. We will meet that survivor properly very soon, and it is not what most people expect a champion of the apocalypse to be, not fast, not fierce, not large, a squat barrel-bodied plant-eater with a face built for grinding, wandering the mudflats in numbers that beg a belief. For now, hold the image of a world where sameness itself is the news. The riot of variety that once filled the Permian is gone, and in its place stands a monotony so complete it is almost eerie. Walk a little further with me along the channel, and let me widen the view because I do not want you to lose the scale of what has happened. Before the dying, the land had known real complexity. There were sprawling communities of early relatives of mammals, the therapsids, in many shapes and sizes. There were sail-backed hunters and burrowers and browsers, and the beginnings of layered food webs with genuine variety at every level. The Permian world was not simple. It had spent tens of millions of years becoming rich. The Great Dying erased most of that richness in what amounts, against the vast clock of Earth history, to a mere geological instant. And here is the cruelty of it. Complexity is expensive to build and cheap to destroy. It took the Permian ages to assemble its intricate tapestry, and the extinction unpicked it in a span so brief the rocks can barely resolve it. What you are standing in now is the long, slow, difficult work of weaving it all back, thread by patient thread, from almost nothing. But rebuilding will not be smooth. The early Triassic climate stays volatile, lurching through hot spells so severe that some regions may have become nearly uninhabitable for parts of the year. Every time conditions stabilize a little, life pushes forward. Every time they swing again, some of that progress is lost. This is recovery not as a clean upward line, but as a stuttering, hard-won climb, full of setbacks, unfolding across a scale of time the human mind can barely hold. And yet, life does climb. That is the quiet miracle threaded through all of this ruin. Out of a planet stripped to a handful of survivors, out of floodplains where one animal wears nearly every face, the machinery of the living world begins, slowly, to reassemble itself. The reef builders will return, though different ones. The food webs will thicken, new predators will rise to fill the empty peaks, and new plant-eaters to feed them. But not quickly, and not yet. The world you're standing in remains impoverished and strange, ruled by the disaster fauna, waiting through its long convalescence. And this is the crucial point, the reason we began our whole tale here in the ash and the heat, rather than in some green and thundering Jurassic dawn. The animals that will one day become the dinosaurs are not the heroes of this moment. They do not yet exist. Their ancestors are among the survivors, unremarkable and unpromising, indistinguishable from the crowd. That is the deep pattern I want you to carry forward as we go. Greatness, in the fossil record, almost never announces itself at the start. The lineages that will inherit the Earth begin as marginal players in someone else's world, small and rare and easy to overlook. The Great Dying did not create the dinosaurs. What it did was clear the stage, empty the theatre, and leave a broken world lying open, so that many millions of years later, when the next catastrophes came, a group of small and unglamorous survivors would find the door standing ajar. For now, though, hold your gaze on these silent floodplains in the aftermath of the worst day the planet ever had. The rivers braid across the drying mud. The ferns nod in a hot, thin wind. The sky is slowly clearing of its ash, degree by degree, century by century. And moving through it all, in numbers that would strain your belief, comes the animal that turned catastrophe into opportunity, the humble survivor whose sheer abundance defined an entire chapter in the recovery of life. You will not meet a dinosaur here, you will not meet a giant. What you will meet is a lesson written in bone and rock across an emptied continent, a lesson about who actually endures when the world falls apart. It is rarely the fiercest, it is rarely the largest. More often it is the flexible, the tolerant, the plain, the ones who can eat the poor food and drink the warm water and keep breeding through conditions that break everything finer than themselves. We have traced the killing from the fishes of Siberia through the warming air and the suffocating seas. We have watched the causal chain run from volcanism to heat to anoxia and acid, and seen why this ranks as the most severe extinction in the whole history of visible animal life. We have opened the great question of recovery and split it honestly into its two speeds, the quick return of species numbers and the far slower rebuilding of a whole working world. And we have stepped into the aftermath, onto floodplains ruled by monotony, where a single kind of creature wears nearly every face in the rock. Everything that comes after grows from this soil, the first small dinosauromorphs creeping into the middle Triassic on the margins, the earliest true dinosaurs, fox-sized and dog-sized, hunting the fern-choked valleys while far larger reptiles ignored them. The long ages of waiting, the climate upheaval still to come, the second great extinction that would finally throw the doors wide, all of it is downstream of this moment, this ruined and recovering world, this emptied stage. So take one last long look across the drying mud before we go on. Fix in your mind how quiet it is, how sparse, how strange. Hold the number, 9 species in 10 swept from the seas, and the deeper truth beneath it, that a broken world heals slowly and unevenly across tens of millions of years. This is the ground floor of the whole tale, the bottom of the deepest pit our planet's life has ever climbed out of. The ash is settling, the rivers are running, and out across those wide and nearly empty plains, the survivors are beginning their long, patient inheritance of a wounded world. Picture the ground first, because the ground is nearly all there is. It runs from your feet in every direction, flat as the skin of a drum. No hills worth the name, no forest wall to catch your eye and hold it, only a floodplain the colour of dried blood and cold ash, running on until the heat smears its far edge into a pale sky. This is the land a short while after the Great Dying, roughly 250 million years ago. The killing is over. The quiet it left is not. You're standing in the aftermath of the worst extinction this planet has ever recorded. About 252 million years ago, near the close of the Permian, something emptied the seas and stripped the land. In the oceans, as many as 9 in every 10 animal species simply ceased to be. On land, the loss cut almost as deep, and the shape of every living community came apart at once. The likely cause lay far away, in what is now Siberia. There the crust cracked open and bled for a very long time. Sheets of lava spread across ground so wide you could not cross it in a year. The eruptions poured carbon and sulfur into the air, and the world answered with heat, with acid oceans, and with water that carried almost no breathable oxygen. Now you stand in what that long fever left behind. Feel the heat before anything else. The air is dry against the back of your throat, and it does not soften when the light fades. Look up, and there is no ice anywhere on this world. Both poles lie open and bare. The land is welded into a single supercontinent, Pangaea, so broad that its centre sits 1,000 miles and more from the nearest shore. No sea wind ever reaches that heart. That interior is a kiln of rock and sand. Deserts run for hundreds of miles, red and shadeless, wider than you could walk in many weeks. There the ground grows hot enough to blister skin by noon, then turns cold as stone by dawn. Rain almost never comes. When it does, it arrives as a brief violence and drains straight away, leaving the sand exactly as parched as before. Look down at what you're standing on. The floodplain is laid in bands, deep red mud stacked against paler layers of grey and near white. The red is old iron in the soil, rusted under a hot open sky. The pale streaks are ash and fine river clay, dropped in quieter seasons. Every band is a page of weather, pressed flat and dry, one thin year of a wounded world resting on the last. Only along the rim of the continent does the air carry real water. There a great seasonal monsoon climbs ashore and lets its rain fall in belts that hug the coasts. Between that soaked margin and the dead interior run the rivers, thin green threads drawn across a red country. You're walking beside one of them now. Keep your eyes low, because the life here keeps its head down. There are no tall trees leaning their weight over the water. The cover is sparse and close to the ground, patches of low green holding to the damp soil near the channel, giving way fast to bare flats beyond. The plants that came through the dying are the tough and the plain, the weeds of a broken world spreading wide because almost nothing is left to crowd them out. Listen and notice how thin the sound is. A living floodplain should be a wall of noise. This one is nearly hollow. The wind drags grit across the flats with a dry hiss. Water turns quietly in the channel. Somewhere a heavy body shifts its footing in the mud, and then, for long stretches, almost nothing at all. The chorus that fills a healthy world has been cut down to a handful of voices. That thinness is not your imagination. It is the physical signature of a planet still climbing out of ruin. The count of species crashed at the extinction, and the true rebuilding of the living web came far slower than the raw numbers alone. Food chains stayed short and top-heavy and unsteady. Full recovery, the kind that stacks predators upon prey upon plants in deep and stable layers, would not settle into place for something near 50 million years. You stand very early in that long convalescence when the world is alive but hardly full. So the plain feels empty because it very nearly is. Cross it, and you meet the same short list of survivors again and again. And of all of them, one animal owns the ground so completely that the whole country seems built around it. It is a stout, low, barrel-bodied creature, about the size of a pig, walking on 4 sturdy legs with its head carried close to the earth. You could rest a flat hand on its back without stooping far. Its face ends in a hard, toothless beak, and 2 short tusks jut from the upper jaw, tools for pulling and rooting up the low plants it lives on. This is Lystrosaurus, and it is not a dinosaur. It belongs to an older branch, the Dicynodonts, beaked plant-eaters that walked the world long before the first dinosaur drew breath. What Lystrosaurus lacks in grandeur it makes up in sheer, staggering numbers. In the rocks that record this age in the Karoo of southern Africa, this one kind of animal accounts for close to 3/4 of every land vertebrate fossil found. In some bone beds the figure climbs higher still, until as many as 19 in every 20 individuals belong to that single genus. Read that again slowly. Nearly the entire cast of a continent reduced to one repeated character. Studies of its bones hint at how it managed the trick. It seems to have grown fast and lived short, hard lives, reaching its size quickly and breeding early, the pattern of an animal built to flood a ruined land before anything could stop it. In a stable world, such haste is wasteful. In a broken one, it is a winning hand, and it was no local success. The same squat survivor turns up in the stone of what are now China, India, Russia, and even Antarctica, which then sat far to the south yet still, remarkably, held no ice. On one joined continent, a single animal spread from end to end, filling ground that in a richer age would have been shared among dozens of rivals. Walk the floodplain and you would feel that dominance in your body. A herd of them moves across the flats ahead, dark backs low to the ground, unbothered, unhurried. There is little here with any reason to hurry them. The great predators that should be trimming such a herd are scarce, still thinned by the catastrophe, still slow to rebuild their numbers and their size, plenty of prey, and almost no one to hunt it. That imbalance is exactly what a wounded world looks like from the inside. The scene has a strange, flattened quality because of it. In a healthy age, your eye would snag on variety. A dozen shapes of body, a dozen ways of making a living layered across a single square mile. Here that variety has been pressed almost out of the picture. The same beaked face crops the same low plants along the same red channel, mile after mile after mile. That is the true texture of this recovering world. Not drama, but sameness. Not a crowded stage, but a wide and simplified one, warm and dusty and quiet, where a small number of hardy shapes have inherited an enormous and half-empty room. The heat presses down, the dust drifts sideways on the wind, the river slides by, and the herd grazes on. You could walk this plain for many days past the same low herds and the same banded flats, and the same thin green thread of the river, and the country would scarcely change its face. On those silent floodplains, one squat survivor was about to become almost the only face you would meet. On those silent floodplains, one squat survivor was about to become almost the only face you would meet. Come down close to the drying mud and look. The animal in front of you stands low and heavy, about the size of a well-fed pig. Its body is a barrel slung between short, splayed legs. Where you might expect a mouth crowded with teeth, there is a blunt beak, hard as a thumbnail, and two small tusks set above it. This is Lystrosaurus. Its moment begins 252 million years ago, in the ash and stillness after the largest dying this planet has ever known. You're standing in the early aftermath, and this beaked creature is about to inherit almost everything. The great burning has passed. In Siberia, vast sheets of lava had poured across the land for a very long time, and the air they poisoned did the killing. Nearly 9 in 10 marine animal species were gone. The forests thinned, the reefs collapsed. On land, the tangled, crowded ecosystems of the late Permian had been pulled apart, and what remained was a thin cast of survivors moving across quiet ground. Into that emptiness walked the beaked ones, and for a while they walked almost alone. Watch the horizon now, and let it teach you what recovery really looks like. It does not look like richness returning. It looks like this. A single kind of animal herded thick as cattle, spread from the near mud all the way to the shimmer of the far distance. In some places you could turn in a slow circle and see nothing but Lystrosaurus. Barrel bodies at every distance, the same blunt beak, cropping the same low plants, over and over, until the eye tires of it. This is not abundance. This is a world so hollowed out that one animal has swelled to fill the whole. The numbers are among the starkest the fossil record has ever handed us. In the rock of South Africa's Karoo, in the layers laid down just after the extinction, Lystrosaurus makes up roughly 73 parts in every 100 of all the backboned animals we can find. In some individual bone beds the figure climbs higher still, toward 95 in every 100 of the actual bodies preserved. Nearly every skeleton you lift from certain beds belongs to the same squat survivor. If you want a single word for what a broken world produces, this is it. Paleontologists call an animal like this a disaster taxon. Lystrosaurus is the one they reach for first, the textbook case, the face of catastrophes' aftermath. And it was not a face confined to one valley. Follow it. The same beaked animal turns up in the rocks of what is now China, and India, and Russia, and even Antarctica. In its own time, all of that ground was stitched together into one supercontinent, Pangaea, a single land mass you could in theory have crossed on foot from pole to pole. There were no ice caps at either end. The interior ran hot and dry, a baked expanse of red sediment, while thin ribbons of green followed the rivers and hugged the coasts. Across that whole enormous stage, from roughly 252 down to about 247 million years ago, one animal set the same broad footprint again and again. To find a single genus that widespread is like finding one weed grown over an entire continent after the garden has been raised. So the question presses in on you, quietly, the way the heat would have pressed on your skin out there. Why this one? Of all the survivors, why did the beaked, pig-sized browser win the empty earth so completely? The answer is not that Lystrosaurus was mighty, clever, or armoured against the world. The answer is closer to the opposite. It won because it was ordinary in exactly the ways that a ruined planet rewards. Start with how it lived and died. When you cut thin slices from its bones and hold them to the light, you find the growth written inside, the way rings are written in a trunk, and the record there suggests an animal living fast. It seems to have grown quickly, bred early, and died young, rather than taking long, slow years to reach a great age. In a calm and crowded world, that is a gamble that rarely pays. In a shattered one, it is close to the only strategy that works. When the ground itself is unstable, when droughts come hard and food vanishes and the sky turns strange, the animal that breeds early and often can flood the land with young faster than disaster can thin them. Lystrosaurus did not outlast catastrophe by enduring it. It outbred it. Add to that a forgiving appetite and a forgiving body. The beak was not a delicate tool. It cropped low, tough, unglamorous vegetation, the kind of hardy plant cover that colonizes bare ground first. It did not need a rich or varied menu. It needed only what a depleted world could still grow. And crucially, it lived in a landscape almost swept clean of the things that might have stopped it. Few competitors reached for the same food. Fewer predators of any size stalked the herds. In a healthy ecosystem, an animal this abundant would be a walking feast, and something large and toothed would rise up to eat it back down to size. But the large and toothed had mostly died, so the beaked survivor multiplied into a vacuum, unchecked from above and uncrowded from the side. Hold those three things together, because between them they explain almost everything you are seeing out to that shimmering horizon. Breed fast, eat anything, meet almost no one who wants to stop you. That is the recipe for a disaster taxon, and it is why a single squat browser could stand in for an entire fauna across half a world. It is worth sitting with how strange that is. The richest empire in the history of that land was built not on strength, but on emptiness. Lystrosaurus was crowned by absence. Before you go on, and before the world you are watching begins its long, slow mending, let me say one quiet thing once. If these journeys into deep time are becoming part of how you rest, follow or subscribe wherever you are listening, on Spotify, on YouTube, or in your podcast app of choice. Then let your attention settle back onto the herds, because now comes the part of the story that most people get wrong. It is tempting to think that recovery was quick. The extinction was sudden after all, so surely the healing snapped back the other way. And in one narrow sense it did move faster than you might expect. New kinds of animals did begin to appear. The count of species climbed back up over the following few million years, and if you only tallied names on a list, you might call the crisis over and move along. This is the trap. Because counting species is not the same as rebuilding an ecosystem, and the two came apart badly in the aftermath of the Great Dying. Think of what a whole, working ecosystem actually is. It is not just a long list of creatures, it is a structure. It is a broad base of plants, feeding a wide band of plant eaters of many sizes, feeding a smaller band of hunters, topped by a few large predators that hold the whole thing in balance from above. It is a pyramid, wide and stable at the bottom, tapering safely to its point. What the survivors built in the early aftermath was nothing like that. It was top-heavy and lopsided and prone to tipping. Whole rolls stood empty. The web of who eats whom, torn apart in the dying, did not simply knit itself back together because a few new names had arrived. You can feel the instability if you imagine leaning on it. A healthy ecosystem is like a wide four-legged table. Push on one corner and it holds. The early Triassic world was more like a tall stool balanced on a single leg. A drought, a heat wave, a bad season, and the whole thing lurched. Populations boomed and crashed. Dominance passed abruptly from one survivor to the next. For a long stretch, the land could not settle into the deep layered stability that had existed before the catastrophe, because the pieces that made such stability possible were still missing, or too few, or not yet arranged in the right order. And here is the figure that should stay with you longer than any other in this whole segment. The true rebuilding, the return of that full, deep, top-to-bottom structure, was not a matter of 1 or 2 million years. Read carefully in the rocks, and the signs of a genuinely restored ecosystem do not appear cleanly until far later in the Triassic. By the best current reckoning, the full recovery was still underway roughly 50 million years after the extinction that started it. 50 million years. Set that against a single human life, and the number stops meaning anything, so do not try to feel it as time. Feel it as distance instead. If the moment of the dying and the moment of full recovery were the two ends of a single day's walk, then the herds of Lystrosaurus you're watching would still be back at the very first mile, with the far end of the journey lost somewhere over the curve of the world. That gap between quick naming and slow healing is one of the quietest, hardest truths in all of paleontology, and it is worth being honest about the seams in it. Scientists debate the exact pace. They argue over which layers of rock mark which stage of the mending, and how fast the base of the pyramid truly refilled, and when the first stable-top predators genuinely locked back into place. What they broadly agree on is the shape of the thing. Life's list of names rebounded first. Life's structure took vastly, achingly longer. You're standing inside that long delay right now, in the company of one beaked animal, on ground that will not be whole again for an unimaginable span. Which raises a fair and stubborn question. How could anyone possibly know that? How do we set one thin layer of Karoo mudstone against a Siberian lava field half a world away and say, with any confidence, that this came first and that came 50 million years later? The mud does not carry a date stamped on it. The bones do not count off the years. And yet the numbers I have been giving you are not guesses pulled from the air. They are measured, and it is worth slowing down to see how, because the whole story of deep time rests on it. The key is not in the mud itself, but in the ash. Again and again, through this long recovery, distant volcanoes coughed fine grey ash across these landscapes, and it settled and hardened into thin pale bands you can still trace along a cliff face today. Those ash layers are the gift, because volcanic ash carries within it tiny tough crystals, some of them a mineral called zircon, each one far smaller than a grain of sand. And locked inside those crystals, from the instant they cooled, is a clock. Here is how the clock keeps its time. When a zircon crystal forms, it traps a trace of uranium, a heavy and restless element. Uranium does not sit still, atom by atom, at a rate that never varies, never speeds up in the heat, and never slows down in the cold, it breaks down and turns into lead. That steadiness is the whole secret. It is the closest thing nature has to an honest, unstoppable metronome. Count how much of the uranium has already become lead inside a single crystal, and you are really counting how many times that metronome has ticked since the crystal first cooled out of the ash. Do the arithmetic, and the ash band gives up its age, often to within a small fraction of a single million years. Now the layers begin to speak in order. Sediment settles the way you would expect, the oldest at the bottom, each new layer pressing down on the ones before, so that a cliff face reads from base to summit like a stack of days. Find an ash band low in the sequence and date its crystals, then find another higher up and date those, and the beds trapped between them are pinned in time from below and above. Lystrosaurus lies in this range, the first mended communities lie in that one, and the volcanic rock of Siberia carries the very same kind of clock, so the burning that began it all can be timed against the recovery that followed, even across an entire hemisphere. That is how you can say, without flinching, that healing here trailed the catastrophe there by tens of millions of years. Not from a story told, but from lead-counted grain by grain inside crystals older than almost anything you will ever touch. So the vast patient numbers are earned, and they leave you with a strange, sober picture of what these early Triassic ages truly were. Not a swift rebound, not a green world springing back, a long, uneven, stumbling convalescence, measured in ash bands and decaying crystals, playing out over a stretch of time so wide that no single animal, no single lineage, no single anything ever saw more than the smallest sliver of it. The herds of Lystrosaurus lived their fast, brief lives and died and were buried, generation upon generation, and the world around them barely shifted. Their whole reign, wide as it was only the opening breath of a mending that was going to take 50 times longer than their kind would last. And they did not last. Slowly, across those hot and unstable plains, the great herds thinned. Other survivors crept up around them, new browsers, new hunters, filling a few of the empty roles the pyramid still held open. The absolute dominion of the beaked one loosened, not in a single dramatic fall, but in the ordinary way that any monopoly frays once the world grows crowded enough to challenge it. The stark scenes of a single face to the horizon gave way to something a little more varied, a little more balanced, though still nothing like the deep richness that had been lost. Stand back one last time and take in the whole of it. A supercontinent baking under a sky with no ice at its ends. Red interior deserts giving way to thin green river corridors. Herds of a squat, tusked, beaked survivor moving across floodplains under a hard sun. The dominant animal of an entire era, and yet only a placeholder. A single held note where a whole chord had once sounded. Above and around them, an ecosystem still missing most of its structure, top-heavy and easily tipped, a full recovery still tens of millions of years out over the horizon. It is a world defined by what is absent as much as by what is present. A world still learning, very slowly, how to be full again. But the emptiness that crowned Lystrosaurus was also an opening. Every role left unfilled, every predator's place standing vacant, every corner of the food web torn loose was for something new, an invitation. A ruined world is a dangerous place to be born. It is also, for the right small body, the widest opportunity the planet ever offers, because nothing established is yet strong enough to keep you out. The great survivors had filled the middle of that world with their barrel bodies and blunt beaks. They had not filled its edges, and it is at the edges, in the quiet margins where the herds thinned and the ground turned strange, that the next thread of this long story begins to pull tight, not among the mighty, not at the centre, off to the side, low and unremarkable in a body no one watching that age would have thought to notice. Somewhere in the banded cliffs of Ishigualasto, a clock is buried in the stone. It is not made of brass or glass. It is a crystal called zircon, no larger than a single grain of sand, and it has been counting steadily since long before the first dinosaur ever drew breath. You would walk right past it, sift a handful of ancient volcanic ash, and you might find only a few. Each is a tiny prism, harder than steel, tougher than the rock that holds it. That stubborn toughness is the first reason it makes such a patient clock. Zircon is born in fire. When a volcano stirs, magma rises and slowly cools, and minerals crystallize out of the melt one at a time. Zircon forms early, while the rock is still molten and searching for shape. As its lattice locks together, it becomes very fussy about what it will let inside. Here is the small miracle that turns a crystal into a clock. Zircon welcomes uranium into its structure. Those atoms slot neatly into the crystal frame, as if the space were made for them, but zircon almost entirely refuses lead. Lead does not fit, and the growing crystal shuts the door on it. So a fresh zircon begins its life with uranium sealed inside, and no lead to speak of. That is the crucial starting condition, and everything else depends on it. Any lead you later find within that crystal was not present at the beginning. It arrived by a slower road. That road is radioactive decay. Uranium is restless and unstable. Over immense spans of time, each uranium atom breaks apart step by step until it finally settles as a stable atom of lead. The pace of that change never once wavers. The rate is fixed, and nothing can bribe it. Heat cannot rush it. Crushing pressure cannot slow it down. Whatever the crystal suffers over the ages, uranium ticks toward lead at the same unbending speed, atom after atom, across hundreds of millions of years. So the lead gathers like sand pooling in the bottom of an hourglass. Count the uranium still waiting to change. Count the lead that has quietly accumulated. The ratio between the two tells you exactly how long that crystal has been sealed and keeping time. The crystal even carries more than one route from uranium to lead, and those separate paths must agree on the answer. When they do, the reading is trustworthy. When they quarrel, something has disturbed the crystal, and a careful worker sets it aside. Now think about where these little clocks are found. Volcanoes do far more than build mountains. They fling fine ash high into the sky, and that grey dust drifts down over everything below. Over rivers, over floodplains, over the bones of the recently dead. Layer by patient layer, the ash settles into the sediment and is buried. In a place like Isigualasto, those ash falls are pressed into the banded rock, pale seams threaded between the deep red mudstones. And each ash seam is a scatter of brand new zircon clocks, every one of them started on the very same day. That is the quiet gift the volcano leaves behind. An ash bed marks a single moment, sealed and ready to be read. Find one just beneath a layer of fossils and another just above, and you have caught those bones in a bracket of time. This is how the great boundaries of deep time were pinned into place. The end of the Permian, when most life on Earth was snuffed out, sits at roughly 252 million years ago. That figure did not come from a guess. It came from zircons in ash, counted grain by grain. The same method fixes the Carnian, that strange humid pulse near 234 million years ago, when the deserts of Pangaea briefly turned to rain. And it marks the close of the Triassic itself, near 201 million years ago, when the world convulsed and emptied once again. The precision is the part that should stop you. Modern laboratories can now date a single ash bed to within tens of thousands of years. Set against boundaries hundreds of millions of years old, that is a razor's edge. It is the difference between a blurred photograph and a sharp one. That sharpness lets you ask far harder questions, not merely when a thing happened, but in what order and how quickly one blow followed another. The crystals begin to tell a sequence, not just a date. Consider the closing of the Triassic once more. As Pangaea began to tear itself apart, vast floods of lava rose along the wound, the immense outpouring called the Central Atlantic Magmatic Province. Those eruptions are the leading suspect in that great dying. Here the fine clocks truly earn their keep. Zircons from the volcanic rocks, and zircons from ash near the boundary, can be lined up carefully against one another. Together they reveal an order of events rather than a single frozen instant. The dating shows that the deep magma was already stirring roughly 100,000 years before the earliest known eruptions broke the surface at the boundary. 100,000 years sounds long to you. Against 201 million, it is a single held breath. That ordering matters more than it first appears. It suggests the poison was gathering underground before the lava ever showed its face above it. Cause and consequence, gently teased apart by crystals no larger than specks of dust. But you should hold all of this with real care, because the clock has honest limits. A zircon tells you only when its ash cooled from the fire. It does not tell you when the animal resting in the next layer down finally died. You are dating the ash, remember, and not the bone. The fossil itself holds no such crystal clock inside it. Its age must be inferred from the datable layers that cradle it, the seams lying above and below the body. So everything rests on a careful reading of the rock, which ash sits under which bone, whether a seam was disturbed, churned by an old river, or slumped out of its proper order long ago. A single crystal misplaced in the layers would keep perfect time for entirely the wrong moment. This is exactly why the work is so slow and so cautious. Geologists trace each pale seam by hand across the whole outcrop. They test whether the layers still lie undisturbed. They gather zircons that agree with one another and quietly discard the strays that do not. An ash bed can also carry older crystals, swept up from ancient rock the eruption tore through on its violent way to the surface. Those borrowed elders would read far too old. Telling the freshly grown grains from the recycled ones is a large part of the craft, and even a good crystal can be scarred. A later heating can let a little lead leak out or a little uranium shift and the clock drifts from the truth. So the reader learns to spot a wounded grain, to trust the clean cores and doubt the damaged rims. None of this makes the method fragile. It makes it honest. Every date carries a stated range, a small window of uncertainty on either side, rather than a single false and tidy number. When a laboratory says 201 million years, it is also telling you plainly how wide that answer might be. Do this work well, and the reward is a calendar for a vanished world. The near-empty aftermath at 252 million years, the warm rains of the Carnian, the final Triassic collapse near 201 million years, each moment anchored by grains of sand. And so, the long recovery from the worst extinction Earth has known is no longer a vague grey fog of ages. It is measured. You can watch the slow years pass, counted out steadily by uranium turning quietly, atom by atom, into lead. Think of it as a field of the smallest clocks imaginable, each one no bigger than a grain of sand scattered through the rock, and every single one keeping the same slow and honest time. They waited in the dark for 200 million years for someone to finally read them. The crystals give those recovering ages a shape you can almost hold in your hand. They let you place yourself precisely inside a world still mending after the deepest wound it had ever suffered. And with that calendar laid open before you, the long healing after the catastrophe becomes something you can watch, patiently, one measured layer at a time. Into that slowly healing world something small and quick was already taking shape along its edges. Into that slowly healing world something small and quick was already taking shape along its edges. Into that slowly healing world something small and quick was already taking shape along its edges. You would have walked past it without a second glance. Picture a lowland in what is now southern Tanzania, roughly 243 million years ago. Geologists call the rock here the Manda Beds. Wide rivers braid across a warm seasonal plain, and ferns crowd the banks in dense green thickets. The air hangs heavy and wet through the growing season, then dries hard when the rains pull back. The big animals are the ones that matter here. Squat tusked plant-eaters move in loose herds. Long-bodied reptiles graze the undergrowth. Crocodile cousins with deep skulls patrol the water's edge, and some of them are longer than a rowboat. Down among the fern stems, close to the warm soil, something else is moving. It is slim, long-tailed, and it walks on two legs in quick, deliberate steps. At the hip it stands no higher than your knee. If it froze between the leaves, you might mistake it for a shadow. This is not a ruler of this world. It is a guest in it, small and rare, threading through the gaps the larger animals ignore. Hold that image, because you're watching the opening of something vast, and it begins almost without a sound. The first dinosaurs, or the animals standing right at their threshold, did not arrive as conquerors. They arrived as whispers. To catch them, you have to lower your gaze past the giants, down to the ankle-high traffic under the ferns. The whisper in the Tanzanian underbrush has a name. Paleontologists call it Nyasasaurus parringtoni. It is one of the strongest candidates we have for the oldest dinosaur ever found, and it lived in the Middle Triassic, in a slice of time known as the Anesian. Reconstructed, it was a modest animal. From the tip of its snout to the end of its long tail, it may have reached about 10 feet, though much of that length was slender, whip-thin tail. Its body, the part that fed and breathed and fled, was small. It weighed as much as 135 pounds at the very most, and quite possibly far less. Set it beside the tusked herbivores of the manderbeds and it would barely reach their bellies. Everything about Nyasasaurus is careful, tentative, hedged. That is not a weakness in the science. It is the honest shape of the evidence. Because here is the strange truth about this creature that may sit at the very root of the dinosaur family. We know it from almost nothing. Consider what actually rests in the collection. A single upper arm bone, a humerus, and a handful of vertebrae from the back. That is close to the whole of it. You could hold what defines Nyasasaurus in the cradle of your two hands. From that scatter of bone, researchers have to ask one of the largest questions in the history of life. Is this a dinosaur, or is it the closest cousin to the first dinosaurs standing just outside the doorway? The answer, right now, is that we cannot be sure, and the people who study it will tell you so plainly. The arm bone carries hints. There is a long roughened crest along the humerus where powerful muscles once anchored, a feature you see in early dinosaurs. The vertebrae show a particular texture, an open, spongy character to the bone that points the same way, but hints are not proof. With so few pieces, a single new fossil could tip Nyasasaurus from inside the dinosaur group to just beyond its edge. So it lives in a careful sentence, either the oldest known dinosaur or the oldest known thing that was almost a dinosaur. Sit with why that ambiguity matters so much, because it changed the timeline. Before Nyasasaurus was properly studied, the earliest widely accepted dinosaurs came from younger rocks, from later in the Triassic. This little Tanzanian animal, if the reading holds, pushes the likely origin of dinosaurs back by as much as 10 to 50 million years. That is not a rounding error. That is a deep extension of the family's history into a world still reeling from catastrophe. So when did dinosaurs really begin? The honest answer is a range, not a date. The origin is generally placed somewhere around 245 to 240 million years ago, in the long, uneven recovery that followed the greatest extinction the planet has known. And that placing leans on more than bones, it leans on footprints. In several parts of the world, faint tracks pressed into ancient mud record small, upright, three-toed feet moving through the Middle Triassic. Trace fossils like these push the divergence of dinosaurs from their nearest relatives to at or before roughly 245 million years ago. The animals themselves are rare in the rock. Their footprints, it turns out, are a little easier to find. Which brings us to a word you will need, because Nyasasaurus did not walk this world alone. It belonged to a wider gathering of animals called dinosaur morphs. Say it slowly. Dinosaur-shaped. These were the close kin of dinosaurs, the branch of the reptile family tree that leads toward birds, sometimes called the bird line. Some of them were dinosaurs. Many were not quite. They shared the upright stance, the long legs tucked beneath the body, the quick bipedal gait. They were built to run, to slip through cover, to move fast in a world that was for them mostly dangerous, and in the same manderbeds of Tanzania, in rocks of nearly the same age, lay one of the most revealing of these cousins. Its name is Acyllosaurus congue, and it belongs to a group called the Coelosaurids. Acyllosaurus is one of the oldest members of the whole bird line ever found, and what makes it precious is that it was not a hunter at all. Look closely at its jaw, and the picture sharpens. The front of its lower jaw did not end in teeth. It ended in a small, hard, beak-like tip, a cropping edge of the kind you might use to nip a stem. Behind that beak sat teeth shaped like little leaves, low-crowned and gently serrated along their edges. These are not the tools of a meat-eater. They are the tools of an animal that browsed on plants, or on plants and small prey together, and that is a quiet revelation. Because the archosaurs that came before, the deep ancestors of this whole radiation, were built to eat flesh. Sharp, curved, blade-edged teeth were the ancestral pattern. Acyllosaurus shows that on the bird line, very early, some of these animals turned toward plants. They evolved the beak and the leaf-shaped teeth independently, on their own branch, long before the great plant-eating dinosaurs of later ages did the same thing over again. Herbivory, in other words, was not invented once near the base of the dinosaur family. It was invented more than once. The same solution, arrived at by separate roads. You're watching evolution rhyme with itself. Think about what that means for the mander beds as a living place. Under the ferns, in the shadow of the tusked giants, there were already two very different kinds of these small upright reptiles. Slim hunters like Nyasasaurus, watching for insects and lizards and anything small enough to seize, and gentle croppers like Acyllosaurus, nipping fronds with a beak no wider than a thumb. The dinosaur experiment at its very start was not a single animal. It was a spread of tiny possibilities, testing different ways to make a living on the margins of a world that belonged to someone else. The Coelophysis, that plant-leaning branch, did not stay in Tanzania. They spread. Across the whole supercontinent of Pangaea, from roughly 245 to 201 million years ago, Coelophysis appear again and again in the fossil record. This was a genuine and lasting radiation, a family that persisted for tens of millions of years, quietly successful in the undergrowth while the headlines belonged to other reptiles. The animal that gave the group its name lived far to the north of Tanzania, in what is now Poland. It is called Silosaurus opolensis, and it comes from a fossil bed near a village called Krasiejał, in rocks of the late Triassic, roughly 237 to 227 million years ago. Silosaurus was larger than its Tanzanian cousin, a slender animal reaching perhaps 6.5 to 7.5 feet long, most of that in neck and tail. Picture something lightly built and leggy, standing about waist-high, cropping low vegetation on a floodplain. Its skeleton is a lesson in convergence, in evolution arriving twice at the same door. Silosaurus had slim, elongated limbs built for walking and browsing. It had the same beak-like tip capping its lower jaw. And along the top of its thigh bone ran a distinctive groove, a small anatomical signature that helps paleontologists recognize its relatives across the world. Lay its body plan beside a much later plant-eating dinosaur, and the echoes are uncanny. The long neck, the cropping mouth, the four-square stance when it paused to feed. And yet Silosaurus was not the ancestor of those dinosaurs. It was a cousin that hit upon a similar shape by itself, on a parallel branch. The resemblance is real. The relationship is more distant than it looks. Here the science grows genuinely unsettled, and it is worth pausing on the uncertainty rather than papering over it. The exact map of this early bird line is still being drawn, and one piece of it moved recently and dramatically. There is a group of small, delicate dinosaur morphs called the Lagopetids. For a long time, paleontologists placed them at the very base of the dinosaur line, as the earliest branching of the dinosaur cousins, the first twig off the trunk that led to dinosaurs. Then, around 2020, a body of new fossil evidence unsettled that whole arrangement. Fresh material, including better skulls, suggested that the Lagopetids might not sit on the dinosaur line at all. Instead, they may belong on the branch that leads to pterosaurs, the flying reptiles. If that reading holds, it means one of the animals we thought stood closest to dinosaur origins was actually kin to a very different lineage entirely. This debate is not settled. Serious researchers hold different views, and the honest position is that the base of this family tree is still being tested, fossil by fossil. You are looking at a diagram drawn in pencil, not ink. That uncertainty is not a flaw in the account. It is what the frontier of a science actually looks like. When you deal with animals known from an arm bone here, a jaw fragment there, a scatter of vertebrae in a drawer, the tree will shift as new bones surface. Each discovery is a small correction, and the shape of the earliest dinosaur world tightens a little with everyone, which returns us to Nyasasaurus, and to one of the quieter, more human episodes in this whole account, and it is very much a detective's tale, because those precious bones, the humerus and the vertebrae that may mark the oldest dinosaur, were not freshly dug from a Tanzanian hillside by the scientist who named them. They had been sitting in a museum collection for a very long time. Go back to the 1930s. Fossil hunters working in Tanzania collected material from the manda beds and shipped it home, as was the practice of the day. Among the crates and drawers were the bones of Nyasasaurus, and there they stayed, labelled, catalogued, quietly shelved. For decade after decade, the possible oldest dinosaur on Earth lay in a drawer, unremarkable to nearly everyone who passed it, its significance unread. Imagine that. The evidence had already been found. It simply had not been recognised. It waited, patient and silent, through most of a century of paleontology. Generations of researchers walked past it. The bones did not change. Our questions did. Only in 2012 did scientists formally study that old material with modern eyes and modern methods, comparing it in detail to the growing catalogue of early dinosaurs and their kin. When they did, the arm bone and the vertebrae told their careful, hedged tale. Old bones, new understanding. It is a reminder that discovery does not only happen in the field, under a hard sun, with a brush in hand. Sometimes the greatest finds are already indoors, resting in a drawer, waiting for someone to ask the right question. The rocks kept their secret. It took fresh eyes to open it. Step back now and take in the whole of this strange early chapter. What sort of world were these first dinosaurs actually living in? Not their world. That is the essential thing to hold on to. The Middle Triassic belonged to other reptiles, and the dinosauromorphs were bit players in a crowded drama. Think about who shared the ground with them. There were the Dicynodonts, stout barrel-bodied plant-eaters with a pair of tusks and a horny beak, some of them the size of cattle, moving in herds across the floodplains. There were the Rhynchosaurs, squat and pig-like and abundant, with wide grinding jaws for shearing tough vegetation, so common in some places that their bones pile up in the rock. And most importantly, there were the crocodile line reptiles, the pseudosutians, the great rivals in this account. These were the archosaurs on the other branch, the one that leads today to crocodiles and alligators. In the Triassic, they were extraordinarily varied and often enormous, deep-skulled predators, armoured plant-eaters, long-legged hunters that could run down prey. Measured against all of that, the early dinosaurs and their kin were minor. A dinosauromorph slipping through the ferns was not the largest animal in view, nor the second largest, nor anywhere near it. It was quick and light and easy to overlook, a knee-high runner in a land of giants. If you had stood on that Triassic floodplain and tried to guess which lineage would one day rule the continents for well over 100 million years, you would almost certainly have guessed wrong. You would have watched the great crocodile cousins and thought, those, not the small quick things underfoot. And that is what makes this moment so quietly astonishing. The animals that would inherit the Earth spent their first many millions of years as extras, small, rare, marginal, threading the undergrowth while the world's attention, so to speak, was fixed elsewhere. There is no sense in the rock that they were destined for anything. They were simply another experiment among many, running on borrowed time and open ground, one of countless shapes the recovering world was trying out. Yet certain traits were already in place, waiting. The upright legs, held straight beneath the body rather than sprawled out to the sides, let these animals move efficiently, cover distance, run when they had to. Some carried the beginnings of the hip and limb features that would define true dinosaurs. Whatever advantages these creatures had were not making them dominant. Not yet. Not for a long time. But the toolkit was assembling piece by quiet piece. On the margins, listen to the mandibeds one more time before we move on. In the growing season, the air is thick and warm, loud with insects, the rivers full and brown. A herd of tusked dicynodonts moves through the middle distance, and you feel their weight through the soil more than you hear it. Somewhere a crocodile cousin slides into the water with barely a ripple, and down at the level of the ferns where the light comes green and broken, a slim two-legged animal the size of a house cat pauses, tilts its head, and darts forward after something too small for you to see. That is the whole scene, the giants in the open, the founders in the shade. For a long span of the Triassic that arrangement held. The dinosauromorphs stayed small, they stayed rare, they stayed on the edges in more than one corner of Pangaea, spreading slowly, browsing and hunting in the undergrowth of a world that had no reason to notice them. If you only had the mandibeds, you might wonder whether these animals were going to amount to anything at all. The evidence there is a promise, not a payoff. But the promise was real, and elsewhere on the supercontinent, in rocks a little younger, that promise begins to take on flesh and bone. To the south and west, in what is now Argentina, there are Triassic beds that preserve not fragments in a drawer, but skeletons. Whole animals, hunters and browsers you can measure from snout to tail, lying in the rock where they fell. There, the small quick creatures of the margins step at last into clear view, and you can finally see what the whispers in the Tanzanian ferns were becoming. The founders had appeared. Now the fossil record was about to show them to us whole, in a landscape stripped bare by erosion, until it resembles nothing so much as another planet. You are the Dinosaur Hour scriptwriter, and this is a writing task, not a tooling task, so I will simply deliver the finished insert. Here is insert A, TTS ready. Roughly 1,800 words, flowing out into your anchor sentence. Consider how thin the evidence can be. The earliest chapter of the dinosaur family does not open with a towering skeleton locked in rock. It opens with a drawer. Go back to the 1930s, to a stretch of what is now Tanzania. A British paleontologist named Rex Parrington was working a band of old red rock called the Manda Beds. These layers were laid down in the Middle Triassic, well over 200 million years ago. Parrington was not hunting dinosaurs. Almost no one was, not there, not then. He gathered what the ground offered, wrapped it, labelled it, and shipped it back to Britain. Among those bones lay a single upper arm, an isolated humerus, and with it a small run of vertebrae from the animal's back. Nothing that looked like a headline. No skull, no claws, no jaw crowded with teeth. Just fragments, the ordinary harvest of a hard field season. And so the bones went into storage, into a museum drawer, catalogued and closed. There they sat, as quiet as a stone forgotten in the pocket of a coat, while decades of the outside world went by. Wars came and ended. Whole theories of how dinosaurs lived rose and fell. And that pale arm bone waited in the dark, touched by almost no one, its importance completely unread. This is one of the quieter truths of paleontology. The fossil does not have to be in the field to be undiscovered. It can be lying in a labelled box a short walk from a scientist's desk and still be a secret. The rock gives up the bone, but the bone still has to be seen. Now and then someone did look. In the 1950s and 60s, a British paleontologist named Alan Turing studied the Manda material. He gave the strange arm bone attention. He even gave it a name in his notes and gestured toward its oddness. Yet the work stayed informal, unpublished in the way that counts. A creature is not truly named until that name is written down, described in the open scientific record and offered to everyone. So the animal hovered in a kind of limbo, studied, suspected, spoken of quietly, and still officially nameless. Think about what that means. For the better part of a human lifetime, one of the most important fossils in the history of the group sat in a drawer, half known and never announced. The ground had done its work long before. The delay was entirely ours. The wait finally ended in the year 2012. A team of researchers returned to those old bones with fresh eyes and newer methods. They published a formal description in a respected biology journal. They honoured the long-dead collector in the animal's name, calling it Nyasasaurus parringtoni, and with that, a creature that had been waiting in silence since the 1930s stepped at last into the light. So what did those few bones actually say? This is where the detective work begins, and it is careful work because the material is so sparse. You're not reading a full body. You're reading an arm and a piece of a spine and asking them to testify about the deepest origins of the dinosaurs. The star witness is that humerus. On the upper part of the bone runs a ridge, a flange of bone where the great chest and shoulder muscles once anchored. Anatomists call it the deltapectoral crest. In Nyasasaurus, that crest is unusually long, stretched down the shaft of the bone far more than you see in most early reptiles. An elongated deltapectoral crest is a trait strongly associated with dinosaurs and their nearest kin. It hints at a particular arrangement of the forelimb, a particular way of carrying muscle. It is the sort of detail a specialist notices at once. The vertebrae add their own quiet evidence. Their internal structure shows signs of the fast, layered bone growth seen in dinosaurs, the kind that suggests an animal that grew quickly rather than slowly. And the tissue carries small chambers and hollows, spaces that in later dinosaurs are tied to the air sac system, the same system that would one day help power the lungs of birds. Put those clues together and you seem to have a dinosaur, or something almost exactly like one. But honest reading means noting what does not fit. Some features of these bones are not clean dinosaur features at all. They sit closer to the reptile just outside the dinosaur line, the near relatives that shared the same body plan without quite crossing the threshold. The animal is a mosaic. It mixes traits from both sides of a line that, this far back, is genuinely blurry. And here the fragmentary nature of the find becomes the whole problem. With a full skeleton, you might settle the argument. You could check the hips, the ankles, the shape of the brain case, the details that cleanly separate a true dinosaur from its cousins. With one arm and a scatter of backbones, you cannot. The bones are suggestive, they are not conclusive, so the team did the disciplined thing. They refused to overclaim. The title of their study asked a question rather than declaring an answer. Nyasasaurus, they concluded, is either the oldest known dinosaur or it is the closest known relative of the earliest dinosaurs. Both readings fit the evidence. Neither can yet be ruled out. That careful hedge is not weakness. It is the sound of science being honest about the limits of a handful of bones. Take a moment to picture the animal those bones imply. Nyasasaurus was not a giant. Nose to tail it may have reached about 10 feet, though much of that length was a long tapering tail. It might have weighed as much as 135 pounds, roughly the mass of a large, lean human. It likely walked on its hind legs, quick and lightly built, a modest hunter or a mixed feeder moving through a world it did not rule, and the world it moved through was ancient almost beyond feeling. These rocks date to around 243 million years ago, in the interval geologists call the Anesian, deep in the middle Triassic. That is a staggering distance in time. It is tens of millions of years before the famous giants, before the long necks and the great horned faces, before anything most people picture when they hear the word dinosaur. Which brings us to why this one draw mattered so much. Before Nyasasaurus was formally described, the oldest widely accepted dinosaurs came from later rocks, from the age called the Carnian, several million years further along. Those were the animals thought to sit at the very base of the family. Nyasasaurus, sitting in the Anesian, is older, meaningfully older. By pushing a plausible dinosaur or a near-perfect dinosaur relative back into these earlier beds, the study shifted the likely origin of the whole group backward by as much as 10 to 15 million years. Let that sink in. A single arm bone, resting untouched in a museum for the better part of a century, quietly moved the birthday of the dinosaurs. Not by refining a date already known, by reaching back into an older world and saying, they may have already been here. Nyasasaurus does not stand entirely alone in those Tanzanian rocks. The same manda beds have yielded another close relative from around the same time, a small, lightly built animal called a Silosaurus. It belonged to the dinosaur forms, the group huddled right beside the dinosaur line, and it carried a surprise of its own. Its lower jaw ended in a small beak-like tip, and its teeth were leaf-shaped, the teeth of a plant-eater or a mixed feeder, not a dedicated hunter. That tells you something important. Even this early, near the root of the family, these animals were already experimenting. Meat-eating, plant-eating, different body plans, all appearing side by side in a single ancient landscape. So the manda beds give you a snapshot of a beginning. Small animals, quick and unremarkable, trying out ways to make a living on a crowded stage. Not yet dominant, not yet destined for anything, just present and diversifying in the shadow of larger reptiles that still owned the world. And Nyasasaurus, that patient sleeper in the drawer, remains the tantalizing edge of the whole picture. It may be the first true dinosaur we have ever touched, or it may be the last close cousin before the true dinosaurs appeared, standing one step outside the door. From an arm bone and a few vertebrae, we cannot yet say which. The honest verdict stays open, and it may stay open until better bones are found in rocks of the same great age. That is the frustration and the beauty of working this far back. The deeper you reach into time, the thinner the evidence grows, and the more each fragment has to carry. A drawer in a museum can hold a revolution, and never announce it. A ridge of bone, length of your hand, can rewrite the opening of one of the greatest families in the history of life. And still, at the end of all that careful reading, you are left with a question rather than certainty. To move past the question, you need more than an arm. You need whole animals, laid out complete in the rock, their hips and ankles and jaws all preserved together, where the diagnosis can be made past any doubt. You need a place where the earliest true dinosaurs left not one bone but many. In beds you can walk through layer by layer. To learn what these newcomers truly were, you must follow the red cliffs south, into a valley that looks like the surface of the moon. To learn what these newcomers truly were, you must follow the red cliffs south, into a valley that looks like the surface of the moon. It lies in the west of what will one day be called Argentina, in San Juan province. People will name it Ishigualasto. They will also call it the Valley of the Moon. 231 million years ago, it is nothing like a dead world. It is a living floodplain, loud with breathing. Picture the ground beneath your feet first. It is banded in colour, deep red mudstone giving way to layers of ash grey and near white. Those pale bands of volcanic clay, dropped from the sky in old eruptions. Later, wind and water will strip this place bare, and the bands will stand exposed in the cliffs. But now they are buried under life. A shallow river cuts across the valley in a slow brown channel. Ferns crowd its edges in a dense knee-high tangle. Stand quietly by the water and feel the air. The interior of this supercontinent runs hot and dry, a parched world with no ice at either pole. But the river corridors stay green. Conifers and cycads throw broken shade across the banks. Damp rises off the mud in the morning, then burns away by midday heat. This is a seam of moisture threaded through a mostly arid land. Now watch the water's edge. Something moves there on two legs. It is lean, quick, and no larger than a big dog. It steps carefully along the bank head low, watching the ferns for the smallest twitch of prey. You're looking at one of the earliest true dinosaurs on Earth, and here is the quiet surprise of this valley. that hunter is not the master of this floodplain. It is one of the smaller things living on it. To understand why, you have to meet the animals themselves one by one. Start with the smallest. Its name is Eoraptor lunensis, the dawn plunderer of the moon. A team led by the paleontologist Paul Sereno found its bones here in 1991 and described the animal 2 years later. It is a modest creature by any measure. From nose to tail tip it runs only about 3 1/3 feet. It weighs roughly 22 pounds. You could lift it in your arms like a full grocery sack and feel it press against your forearm, warm and light. Almost nothing about its size announces the empire its descendants will build. But look inside its mouth, and the puzzle begins. Eoraptor carries 2 different kinds of teeth at once. Up front, in the upper jaw, sit curved, serrated blades, the kind of teeth you would expect on a meat-eater. Further back, and in the lower jaw, teeth flatten into simple leaf shapes, the kind better suited to cropping plants. It is a mouth built as if 2 different animals had been stitched together. Paleontologists call this arrangement heterodont, meaning many-shaped teeth. For a long time, those mixed teeth pointed to a simple answer. Eoraptor, the reasoning went, was an omnivore, taking small prey and soft plants alike. It was cast as a generalist, an opportunist near the very base of the dinosaur family tree. That reading fit its uncertain place in the family. Even now, scientists debate whether Eoraptor sits closer to the meat-eating theropods or to the long-necked plant-eaters that came later. Then a close relative reopened the question. Its name is Buryolestis schultzi, an early cousin found in the older rocks of southern Brazil. When paleontologists studied Buryolestis carefully, they found a mouth built for meat, sharper and more clearly predatory than expected for an animal on the plant-eater's branch. That discovery sent them back to Eoraptor with fresh eyes. Perhaps its leaf-shaped teeth had been read too generously. Perhaps this little animal leaned more toward hunting than anyone had assumed. The debate is honest and still open. When you watch Eoraptor stalk the fern beds, you are watching an animal whose very diet remains unsettled science. Now let a larger shape move through the ferns, and the scale of this valley shifts. This is Herrerasaurus ishigualastensis. It is named for the man who found its first bones, a rancher called Victorino Herrera, who spotted them near San Juan in 1959. Herrerasaurus is a genuine predator, a lean, upright hunter running anywhere from 7 to 13 feet from snout to tail. Set it beside little Eoraptor, and the difference is stark. One you could carry. The other could look you level in the eye and outweigh you many times over. Herrerasaurus matters far beyond its size because of a single hole in its hip. Reach, in your mind, to where the thigh bone meets the pelvis. In most reptiles, the head of the thigh bone rests in a solid, closed cup of bone. In Herrerasaurus, that cup is open. It is a window straight through the hip, a perforated socket that the ball of the femur slots into from the side. This feature has a name, the perforated acetabulum, and it is the single anatomical hallmark that defines a true dinosaur, separating this lineage from all the other reptiles sharing its floodplain. When you see that open hip, you are looking at the signature of an entire dynasty, already written in the bone. Yet the same animal carries an older secret in its hand. Later, meat-eating dinosaurs will walk the earth with 3 fingers, or fewer. Herrerasaurus still has 5. Its hand is a primitive, almost grasping thing, a holdover from ancestors that had not yet trimmed themselves down. So here is a predator with a fully modern dinosaur hip, and an old-fashioned 5-fingered hand on the same body. Paleontologists call this a mosaic, a mix of advanced and ancient traits worn at once. That mosaic fueled decades of argument about exactly where Herrerasaurids belong on the dinosaur family tree. Most researchers now place them as an early branch of the meat-eating side. The finer details are still worked over, quietly, in the journals. One more feature reveals how Herrerasaurus made its living. Run your attention to its lower jaw. It is not a single rigid bar of bone. Partway along its length sits a flexible hinge, a joint within the jaw itself. This intramandibular joint let the lower jaw bow slightly as it closed. When Herrerasaurus seized struggling prey, that small flex would have let its teeth grip and hold rather than simply crush and slip. It is a subtle mechanical detail, visible in the fossil skull, and it tells you plainly what this animal was. A predator built to keep hold of things that fought back. So already, in one valley, in one narrow window of time, you have two dinosaurs living utterly different lives. A 22-pound generalist worrying the fern beds, a hunter 3 or 4 times its length gripping prey with a flexing jaw. And they are not the only ones. Move again, and a third dinosaur crosses the same ground. This one is called Eodromaeus Murphy, the Dawn Runner. It is small and lightly built, roughly the size of a large dog, a slender biped made for speed across open floodplain. It was found at the very base of these beds, in the oldest layers, right alongside Eoraptor and Herrerasaurus. Its exact identity is still argued. Some researchers read it as an early meat-eater, a true theropod. Others place it nearer the ancestry of the long-necked giants to come. Even at the dawn, the family tree is tangled. What makes Eodromaeus so important is the company it keeps. It did not live alone with the other two. In these same lowest, oldest beds, paleontologists have pulled up more names. There is Panphagia, whose name means eater of all things, a small early member of the long-necked lineage. There is Chromogosaurus, another early plant-eater's cousin from the same branch. Together with Eoraptor, Herrerasaurus, and Eodromaeus, they crowd the base of this formation. Sit with what that means. This is the late Carnian age, only a few million years after dinosaurs likely first arose. And already, in one corner of the supercontinent, the group has split into several distinct lineages living side by side. Meat-eaters, the ancestors of the longnecks, ambiguous forms that resist easy sorting. This is not a single experimental animal clinging to survival. It is a small radiation, a fan of related forms testing different ways to make a living on the same floodplain. Dinosaurs, it turns out, diversified early, long before they grew large or common. And the Valley of the Moon holds even more than these animals. The whole park preserves something rare on Earth. Its layered rock records roughly 50 million years of continuous Triassic time, stacked across 6 distinct formations. You can walk from older beds to younger beds and read the slow turning of an age in the cliffs, the rise of the dinosaurs written from their first faint appearance through their spread. Few places anywhere offer such an unbroken page. But do not let this one valley fool you into thinking it stood alone. Follow the red beds beyond Argentina, across ancient river systems, into what will one day be southern Brazil. There, in the state of Rio Grande do Sul, lie rocks called the Santa Maria Formation, and they are older still. Radiometric dating places parts of the Santa Maria Formation near 233 million years old. That makes them some of the oldest dinosaur-bearing rock known anywhere on the planet. In these beds walk Styracosaurus preci, a small to medium hunter and a member of the same Herrerasaurid family as the great gripping predator of Ischigualasto. Styracosaurus is one of the earliest dinosaurs known from South America outside Argentina, a lean bipedal killer stalking an even earlier chapter of the same story. And it does not walk that ground alone either. The Santa Maria beds hold early members of the long-necked lineage as well. There is Bureolestes, the very animal whose carnivorous mouth reopened the argument over Eoraptor. There is Pampodromaeus, and there is Saturnalia, both early relatives of the giants that will one day shake the earth. So across 2 regions of southern Pangaea, in rocks separated by only a couple million years, you find the same pattern. Meat-eaters and the ancestors of the longnecks, small, quick and already branching, laid down together in the oldest dinosaur graveyards we have. Take a step back now and hold the whole picture in view. In this narrow slice of the late Triassic, in these red and grey valleys of the far south, the dinosaurs have arrived. They come in more than one shape. They come as light plunderers and lean hunters and dawn runners. They are diversifying with genuine speed, spreading their lineages across the floodplains in what amounts, on the scale of deep time, to a geological instant. Everything about them, seen with hindsight, looks like the opening of an empire. And yet here is where the honesty of the fossils cuts against the drama. Because if you had actually stood on that Isigualasto floodplain, you would not have noticed the dinosaurs at all. You would have noticed the others first. The ground here belongs to animals that are not dinosaurs, and most of them dwarf the little hunters entirely. Great numbers of rhynchosaurs move through the vegetation, stout pig-shaped plant-eaters with beaked snouts, cropping the ferns in bulk. They are among the most common large animals in the valley, and they are built like living barrels. Beside them browse the dicynodonts, heavy, tusked plant-eaters descended from the survivors of the old catastrophe, moving in slow herds across the flats. In sheer weight of flesh, these herbivores are the true owners of the floodplain, and the small dinosaurs merely dart between them. Watch the predators, and the lesson lands harder. The most fearsome hunters here are not dinosaurs at all. They belong to the crocodile line, the great branch of archosaurs sometimes called the crurotarsans. Some of these reptiles are many times the size of Herrerasaurus. They patrol the same riverbanks, take the same prey, and command the largest predatory roles in the whole ecosystem. When one of them moves through the ferns, the little dinosaurs give way. The sound of this world, the low crash of big bodies through undergrowth, the bellow across water, belongs mostly to animals whose descendants are crocodiles, not to the ancestors of the birds. So the scene resolves into its true proportions, a floodplain ruled by the bulk of rhynchosaurs and dicynodonts, patrolled by crocodile-line giants at the top, and threaded through all of it, small and quick and easy to overlook, the earliest true dinosaurs, going about the modest business of survival in the gaps left by larger things. They carry the open hip, the flexing jaw, the mixed teeth, the branching lineages. They carry in short every promise of what is to come. But promise is not power. If you weighed this valley by pounds of flesh, by size of predator, by control of the best niches, the dinosaurs would barely register. They are the marginal players in their own origin story, sharing the ground with creatures that outnumber and outweigh them at every turn. Hold the whole assemblage in your mind for a moment, and let it settle into order. Picture the earliest dinosaurs as stones gathered from a single riverbed, each a different weight resting in your open palm. You could sort them the way a child sorts pebbles, smallest out at the fingertips, heaviest down against the wrist. Isigualasto gives you enough of them to try that. This one formation, in San Juan province in northwestern Argentina, holds several of the oldest dinosaurs anyone has ever put a name to. Together, they are not a crowd. They are a handful. But a handful is where every dynasty begins. Start with the lightest stone, Eoraptor lunensis, a name that carries the dawn and the moon inside it, measured about 3 1/3 feet from snout to the tip of its tail. It weighed roughly 22 pounds. That is no more than a mid-sized dog curled asleep at your feet, and much of that modest length was slender neck and the long whip of a tail. It was a gracile, lightly built thing, quick over the ground, easy to overlook. Paul Sereno and his team lifted it out of the red beds in 1991. They described it formally 2 years later, in 1993. Small as it was, its mouth held a quiet puzzle. Look closely at the jaw. Toward the front sat curved, serrated blades, the kind of teeth you expect in a meat-eater. Further back, the teeth flattened into leaf shapes, the kind you find in animals that crop plants. One mouth, built as if from 2 different animals stitched together. For years that mix was read as the signature of an omnivore, something that took whatever the floodplain offered. That reading is no longer settled. A close cousin named Burialestes turned out to be more strictly a hunter than anyone had expected, and its teeth reopened the question. Some now wonder whether Eoraptor leaned harder toward meat than the older textbooks allowed. The stone in your palm is light, but the argument over what it ate is still very much alive. Set Eoraptor down and reach for something heavier. Herrerasaurus isquigualastensis, Herrera's lizard, runs from roughly 7 feet to as much as 13 feet nose to tail. This is a real predator, lean and bipedal, tall enough at the hip to look a crouching person in the eye. Its first bones came to light in 1959, found by a rancher named Victorino Herrera in the Badlands near San Juan. He gave the animal nothing but his attention, and it carries his name still, long after anyone guessed how important those bones would become. Run a finger over what makes Herrerasaurus a dinosaur at all, look at the hip. Where other reptiles carried a closed cup of bone to seat the thigh, Herrerasaurus had an open socket, a clean hole punched through the hip. That perforated hip is the single hard hallmark that separates true dinosaurs from their many relatives, and yet the same animal keeps an older habit in its hands. Each hand carries 5 fingers, not the trimmed 3 of later hunters, a grasping, almost primitive structure hung off an otherwise advanced body. It is a creature caught mid-sentence, half a thing that was half a thing to come. That mosaic kept scientists arguing for decades over exactly where it belongs on the family tree. There is one more detail worth feeling in the skull. The lower jaw of Herrerasaurus had a loose joint set partway along its length, a hinge inside the jaw itself. When the animal bit down on struggling prey, that joint let the jaw flex and hold, tightening the grip rather than letting a thrashing meal tear free. You can read the mechanism in the fossil bone, a small piece of engineering built for a single violent moment. Now the middle stone, sized between the other two. Eodromaeus murphy, the dawn runner, stood about as tall as a large dog and was built for speed, light on its feet, long in the shin. It shared the very base of the formation with Eoraptor and with Herrerasaurus, 3 dinosaurs pulled from the same old ground, and it did not stand alone among its kin. In the same beds lie Panphagia and Chromogosaurus, early plant-leaning members of the line that would one day swell into the long-necked giants. Lay them all out together, and the point becomes plain. Within only a few million years of the group's first appearance, the dinosaurs of southwestern Pangaea had already split into several distinct shapes: hunters and browsers, runners and grazers. They were rare, they were small, but they were branching. And branching is the beginning of everything that follows. Carry your palm north and east now, across what is today the border into southern Brazil, into rock of nearly the same age. There the Santa Maria Formation holds Styracosaurus praesei, a slim bipedal predator and a close relative of Herrerasaurus. Its rock has been dated to around 233 million years, which places it among the very oldest dinosaur-bearing beds anywhere on Earth. Styracosaurus does not lie there by itself. Around it rest some of the earliest long-necked ancestors, animals with names like Bureolestis, Pampodromeus, and Saturnalia. These were not yet giants. Saturnalia was a slender thing you could have lifted in your arms, a far cry from the 100-foot sauropods its descendants would one day become. But the blueprint is already there in the stone, folded small, waiting. Hold the whole set now, the Argentine stones and the Brazilian ones together, and you are holding a spread of only a few million years, gathered from 2 patches of a single vanished continent. That is worth pausing on. If you follow or subscribe wherever you are listening, on Spotify, on YouTube, or in your podcast app of choice, you can keep walking these old riverbeds with me, because the ground that holds them is itself a kind of ledger, and the ledger has more to say. Consider where these Argentine animals come from. Isquigualasto sits inside a protected park in San Juan province, a place people have long called the Valley of the Moon for its bare, banded, lunar-looking badlands. Those cliffs are stacked in horizontal bands of deep red mudstone, ash grey and near white, each layer a page of old river mud and settled volcanic dust. It looks lifeless now, wind-carved and dry. But turn the pages back, and the moonscape becomes a living floodplain, threaded with shallow river channels and choked with ferns, warm and green along the water while the vast interior of Pangaea baked dry beyond it. That is where the small hunters walked, in and out of the shade close to the streams. Read from bottom to top, the park preserves something close to 50 million years of continuous Triassic time, laid down across 6 distinct rock formations, one atop the next without a major gap. The whole sequence is listed as a World Heritage Site, valued precisely because it records the rise of the dinosaurs from their first faint appearance through their long, slow spread. That is the rare gift of the place. Most fossil sites are a single frozen window, a snapshot of one moment. Ischigualasto is a film reel. You can walk uphill through the layers and walk forward through time, watching which animals come and which go, counting how the small forms at the bottom give way, bed by bed, to different casts above them. So lay the stones out one last time along your open hand. Eoraptor at the fingertips, light as a house dog, its diet still quietly disputed. Eodromaeus beside it, the runner, all shin and balance. Herrerasaurus down toward the wrist. The true predator with the open hip and the 5 old fingers and the flexing jaw. Styracosaurus carried over from Brazil, near the oldest edge of the whole record. Each one real, each one measured, each one pulled from banded rock you could stand in front of and press your hand against. Sorted by size, they make a tidy little row, the entire beginning of a dynasty small enough to cup in one palm, and here is the thing the numbers keep whispering. Every one of these creatures, even lean 13-foot Herrerasaurus, was a modest figure on its own floodplain. Bulky beaked plant-eaters browsed past them in herds. Crocodile-line reptiles, some many times their weight, patrolled the same riverbanks and looked down on them from above. The stones in your hand are the founders of a line that would one day hold the whole earth. But on the day they lived, they were among the smaller shapes moving through the ferns. That is the strange truth the ledger returns to. These were the first of their kind, the earliest unambiguous dinosaurs, clever and quick and already branching. Yet for all their promise, these hunters were not the ones who ruled the ground beneath their feet. Yet for all their promise, these hunters were not the ones who ruled the ground beneath their feet. Yet for all their promise, these hunters were not the ones who ruled the ground beneath their feet. Widen your eyes for a moment past the small predator you have been following. Look to the far bank of the river. Something much larger is moving through the reeds. It walks low and heavy on 4 pillared legs, its skull as long as your whole arm. Its back is ridged with bone. When it steps into the shallows, the water shoulders aside in slow brown folds. Beside that animal, the dinosaur at the water's edge looks like a terrier trotting past a draft horse. That comparison is close to the literal truth of this world. For most of the Triassic, the large animals on land were not dinosaurs at all. They were crocodile-line reptiles, the pseudosuchians, sometimes called crurotarsans for the distinctive hinge in their ankles. They were the cousins of dinosaurs, sprung from the same deep archosaur root after the Great Dying, and for something like 30 million years, they won. They owned the big bodies, the big teeth, the commanding positions in every food web across the supercontinent. You need to feel how thoroughly they won, because it reshapes the whole story you think you know. The dinosaurs of the late Triassic were not lords-in-waiting striding toward an obvious throne. They were the small ones, the quick ones, the animals living at the edges of a world that belonged decisively to someone else. Consider the scale first, since scale is what your eye reads before anything else. Your little riverbank hunter, an Eoraptor, stood about 3 feet long from nose to tail tip. It weighed roughly 22 pounds, about what a mid-sized dog carries. A grown Herrerasaurus was larger, reaching perhaps 13 feet in the biggest individuals, but still lean, still light, still built like a runner rather than a wall. Now set those animals beside the crocodile-line giants that shared their floodplains. Some of those predators grew to lengths that would have swallowed a Herrerasaurus in their shadow. The dinosaurs were not the terror of this valley. They were, at best, the middle managers of a company owned by their cousins. There is a way to measure this dominance that goes beyond raw size, and it is one of the most important numbers in the whole Triassic. Paleontologists studied the anatomy of these two groups across the same stretches of time tallying how many different body plans each lineage explored. Not how many species, but how many genuinely different ways of being an animal. Long snouts and short snouts, armoured backs and bare ones, meat-slicing teeth and plant-cropping beaks. When the counting was done, the Cruratarsans came out ahead by a wide margin. They held roughly twice the anatomical variety of the dinosaurs living alongside them. Sit with that figure. Twice the variety. It means the crocodile-line reptiles were not simply bigger, they were more inventive, more flexible, more thoroughly spread across every job an ecosystem offers. There were pseudosuchians built as heavy ambush predators. There were others plated in bony armour like living tanks, grazing low through the ferns. There were slender, upright forms that ran on long legs, converging on the very shape we now think of as dinosaurian. If you had walked this floodplain and been asked which lineage looks destined to inherit the earth, you would not have pointed at the terrier. You would have pointed at the draft horses every time. Before we go further into that world, one quiet note for you, wherever you happen to be resting tonight. If these long walks through deep time are the kind of thing you want more of, follow or subscribe wherever you're listening, on Spotify, on YouTube, or in your podcast app of choice. Now, back to the valley, and the animals who owned it. So where did the dinosaurs actually live, if the good positions were all taken? They lived at the margins. Think of frost on an autumn morning gathering first at the rim of a pond, while the open centre stays dark water. The dinosaurs were that frost. They collected at the edges of the ecosystem, in the rolls too small or too fast or too marginal for the giants to bother defending. They were present, they were persistent. But they were pushed to the cold rim of the pond, and the centre was not theirs. Around them moved a caste of animals most people have never heard of, animals that were, in their own day, far more important than any dinosaur. There were the rhynchosaurs, squat plant-eaters with barrel bodies and strange beaked skulls, built to shear through tough vegetation. They gathered in numbers, browsing low, and in many late Triassic sites their bones outnumber everything else combined. Where you find one rhynchosaur, you often find dozens. They were the cattle of this landscape, and the dinosaurs threaded between them like foxes between grazing herds. There were the dicynodonts too, the beaked mammal relatives, some of them heavy and bull-shouldered, moving in loose herds across the open floodplain. These were the last great survivors of a lineage that reached all the way back before the extinction, back to the little pig-sized Lystrosaurus that once made up almost the entire land fauna of the recovering world. Their descendants still carried the ground here, chewing through vegetation with beaks of horn, their tusks worn from rooting. When you imagine the sound of this place, do not imagine the roar of a dinosaur. Imagine the low shuffle and grind of dicynodont herds, the rustle of rhynchosaurs in the ferns, and cutting through it all, the heavier tread of the crocodile line hunters on patrol. The dinosaurs, by contrast, were probably quiet. Small bodies make small sounds. A 22-pound Eoraptor slipping through the understory would have left barely a whisper, a stir of fronds, a shadow gone before you fixed on it. That quietness was not weakness, it was strategy. When you are the small one in a world of giants, silence is a way to stay alive. Now here is the question that should be forming in your mind, the one paleontologists themselves wrestled with for decades. If the dinosaurs were so thoroughly outmatched, so small and marginal and outnumbered, then how did their descendants ever come to rule? And the harder version of that question, the one that turns the whole tidy narrative upside down, was there ever anything special about them at all? Hold that thought. We will return to it, because it sits at the centre of everything. First, though, let us do the dinosaurs justice, because being small and marginal was not the same as failing. It is easy, looking back across the deep gulf of time, to read the Triassic dinosaurs as also rans, animals treading water while they waited for their moment. That is a trick of hindsight, and hindsight lies. In their own day, these animals were not waiting for anything. They were succeeding on their own terms in the roles available to them. Consider what small size actually buys an animal. A small predator needs less food. It can survive on prey too meager to interest a giant, on insects and lizards and the young of larger animals. It can hide where big bodies cannot follow, in burrows in dense brush, in the tangle of a fallen log. When times turn hard, and in the Triassic times often turned hard, the small and the flexible are the ones who slip through. Being a terrier in a world of draft horses is not a tragedy. It is a different and perfectly good way to make a living. Look closely at the anatomy of these early dinosaurs, and you see bodies built for exactly that life. The lean, upright legs held directly beneath the body, giving an efficient striding gait that sipped energy rather than gulped it. The light, hollowed bones that kept the whole animal quick and cheap to run. The grasping hands, still primitive in a form like Herrerasaurus, which kept 5 fingers where later hunters would have 3, yet flexible enough to seize and hold. Even the jaws tell the story. Herrerasaurus carried a subtle hinge partway along its lower jaw, a joint that let the bone flex just slightly as it bit down. On a struggling meal, that flex meant a better grip, a mouth that could clamp and hold rather than simply snap, and the teeth. In Eoraptor you find one of the strangest mouths of the early dinosaur world, a jaw that seemed stitched together from 2 different animals. Toward the front sat curved, serrated blades, the teeth of a meat-eater, made for slicing. Further back sat flatter, leaf-shaped teeth, the kind you find in animals that crop plants. What does an animal do with a mouth like that? Most likely it ate whatever it could get. Small prey when small prey was there, soft plants and shoots when it was not. That flexibility, that willingness to take the meal in front of you rather than specialize on one narrow food, is exactly the toolkit that keeps a small animal alive through lean and shifting years. So the marginal life of the early dinosaurs was not a holding pen. It was a holding pattern in the truest sense. These animals were circling, staying aloft, keeping their options open, waiting out weather they could not control. They were not building toward dominance through some inner drive to greatness. They were simply surviving generation after generation in the cold frost at the rim of the pond, while the warm centre belonged to their cousins. Which brings us back to the hard question, the one still hanging over the valley. When the dinosaurs finally did inherit the Earth, was it because they were better? Or because they were lucky? For a long time, the answer felt obvious, almost too obvious to examine. Of course, the dinosaurs won because they were superior. They stood upright on efficient legs. They may have run warmer and faster than their sprawling cousins. The old textbooks told a tidy tale of competition, of nimble dinosaurs outcompeting sluggish crocodile-line reptiles across the Triassic, gradually elbowing them aside until the throne was theirs. It was a satisfying story. It flattered the winners. It fit the way we like to imagine history as a ladder climb by the deserving. The trouble is that the rocks do not support it. When paleontologists actually measured the 2 groups against each other, tracking their variety and their rates of change straight through the late Triassic, they found no sign of dinosaurs pulling ahead. None. Right up to the end, the Cretaceans were holding their own and more. They were more varied. They were often larger. They were doing, by every measure the fossils preserve, at least as well as the dinosaurs, and frequently better. There is no slow, grinding, competitive victory written in the stone. There is instead a picture of 2 lineages running neck and neck, with the crocodile-line reptiles arguably in the lead. That finding lands like a stone dropped into still water, and the ripples reach everything. Because if the dinosaurs were not winning through the whole Triassic, then their eventual triumph cannot be explained as the payoff of long, patient superiority. Something else happened, something from outside the contest, and that possibility, that the greatest dynasty in the history of land animals began not with merit but with an accident, is one of the genuinely unsettled and thrilling questions in all of paleontology. Notice what this does not mean. It does not mean the dinosaurs were poorly built or fragile or doomed. Clearly they were capable animals, or they could not have seized the moment when it came. But capability is not the same as destiny. The world is full of well-built creatures that never got their chance, because chance never arrived, or arrived and favoured someone else. What the fossils suggest is that the dinosaurs were good enough to win if the board were cleared, but not so dominant that they could clear it themselves. They needed the board cleared for them, and the clearing, when it came, would come from forces no animal could contest. We will let that loop stay open a little longer, because it deserves its resolution, and its resolution belongs to what comes next. For now, hold both truths together. The dinosaurs were genuinely well-made animals, and their rise was not guaranteed by that fact. Both things are true, and the tension between them is the real drama of the Triassic, far more interesting than any simple tale of the best team winning. Let me set you down inside one ordinary day in that world so the abstractions become a place you can stand. It is a morning in the valley we now call Isigualasto, in the rock we now read as roughly 231 million years old. There is no valley yet, of course. That comes later, carved by erosion long after everything here is dead and buried. Right now it is a living floodplain, threaded by shallow rivers, hemmed by fern and low conifer, under a sky that has not seen rain in weeks. The interior of the supercontinent is dry and hot, and this green river corridor is a thin ribbon of life running through a parched land. You are standing in the shallows, and the water is bath-warm around your ankles. Underfoot the sediment is banded in colours, deep red mud giving way to streaks of ash-grey and pale near white. The leavings of old floods and distant volcanoes layered like the pages of a closed book. The air smells of green rot and warm silt, insects hang in the slanting light, and a Herrerasaurus is coming down to drink. It moves the way a heron moves, deliberate and low, each foot placed with care. You could hold most of its length in your gaze at once, 7 or 8 feet of lean muscle balanced over 2 striding legs, the long tail held out straight behind for counterweight. Its hide is dry and dull, the colour of the mud it walks on. Its eyes track sideways as it walks, reading the reeds. This is a predator, but not a confident one. It carries itself like an animal that knows it is not the biggest thing at the water. Watch the hips as it steps. There, if you could see through the skin, is the single feature that marks it as a true dinosaur. The small detail that separates it from every crocodile-line cousin on the far bank. Where the thigh meets the pelvis, the socket is not a solid cup. It is an open window, a hole clean through the bone, and into that opening the head of the thigh fits like a peg. That perforated hip is the quiet signature of the dinosaur lineage, the structural gift that let these animals stand tall and stride far. The giant across the river does not have it. You are looking at 2 different solutions to the same problem of walking, and only one of them will still be walking 140 million years from now. The Herrerasaurus lowers its head to the water. It drinks in quick, wary sips, lifting its snout between each one to scan the bank. Downstream, a cluster of rhynchosaurs shoulders through the reeds, ignoring it, their beaked faces down among the fronds. They are too many and too bulky to be prey. The hunter is not interested in them. It is listening for something smaller, a rustle in the brush, the scrape of a lizard, the panic of a young animal that has wandered from its herd. And all the while, on the far bank, the true owner of this valley lies in the shade. One of the great crocodile-line predators, longer and heavier than anything the dinosaurs can field, rests with its belly in the cool mud, eyes half-lidded, in no hurry at all. It does not need to hurry. Nothing here challenges it. When it wants to eat, it will eat. The Herrerasaurus keeps one eye on that shape across the water the entire time it drinks, and when a breath of wind stirs the reeds near the resting giant, the little hunter is already 3 strides gone, folding itself back into the ferns without a sound. This is the shape of every day here. The small stay watchful, the large stay comfortable. The frost holds to the rim while the centre basks, and it has held this way for so long through so many generations of hunters coming down to this same warm water, that it must have looked eternal. If any awareness could have surveyed this valley, it would have seen no reason for the arrangement ever to end. The crocodile-line reptiles were varied. They were vast, they were unchallenged. In what looks to us like a single unbroken chapter, though in truth it spanned tens of millions of years, they held the world in their jaws and did not loosen their grip. But the arrangement was not eternal. It only looked that way from inside a single lifetime, or a single day at the water. Stretch your view wide enough to take in the deep pulse of the planet itself, and you begin to see that the stability was borrowed. The climate that fed this green corridor was about to lurch. The volcanoes that laid down those pale ash bands were rehearsing for something far larger. The board that the dinosaurs could never clear for themselves was going to be cleared twice over by the Earth. None of the animals at this river could sense it. The Herrerasaurus finishing its drink, the rhynchosaurs deep in the ferns, the great predator dozing in the mud, none of them registered the slightest warning. In what would prove, across the long reckoning of the rocks, a mere geological instant, the terms of survival themselves were about to be rewritten, and rewritten by forces that had nothing to do with who was faster or larger or better made. The contest between dinosaur and crocodile cousin, run so long and so evenly, was not going to be decided on the floodplain at all. Because the thing that would finally break the Cruritarson's grip, the thing that would at last let the small quiet hunters step up out of the margins and into the centre of the pond, was not another animal. It was not a rival, not a competitor, not a better body plan. It was the world itself, convulsing. It was carbon and ash and heat, poured into the sky until the sky could no longer hold the balance steady. When that came, the difference between winning and vanishing would not be earned. It would be survived, or not. The dinosaurs had done their part already. They had stayed small when small was what the world allowed. They had stayed flexible, stayed quick, stayed alive at the cold edge for 30 million patient years. That was the whole of their preparation, and it would turn out to be enough, though not for any reason they controlled. They had endured. Now the world was about to test what endurance was worth. The light comes to the river margin slowly, grey before it turns gold. You are standing at the edge of a shallow channel, in a place that will one day be called the Valley of the Moon. This is Isigualasto, in the far southwest of a single-joined continent, roughly 231 million years ago. The water moves without hurry over banded beds of red mud and ash-grey clay. Ferns crowd the low ground, and their fronds hang heavy with the night's damp. A hunter is already awake here. It is a Herrerasaurus, and it walks the waterline on 2 legs. Measured nose to tail, it runs somewhere between 7 and 13 feet, lean through the chest and long in the shin. You would not call it large. Along this same floodplain there are animals many times its weight, yet it carries itself like something that expects the ground to hold still for it, chin low, tail held stiff and level behind. The river chill rises as it steps into the shallows, climbing its legs the way cold water slowly fills a boot. It does not flinch. The cold is simply the first fact of the morning, read once and set aside. Its breath shows faintly in the cool air above the channel. Out in the ferns, water drips from frond to frond, a soft irregular ticking that never quite settles into a rhythm. The floodplain is not quiet. Off in the mist, low and heavy, a herd of stout beaked reptiles moves through the undergrowth. These are rhynchosaurs, barrel-bodied plant-eaters with cropping jaws, and they browse in loose numbers along the greener margins. They are not prey. The hunter takes lightly. Many of them outweigh it, and a startled one can turn and shove with real force. So the Herrerasaurus watches them without committing. It is looking for something smaller, or something careless. You can follow the way it hunts by the way it holds its head. The eyes track low, along the tangle where the ferns meet open mud. A young rhynchosaur strayed from the herd. A lizard-shaped reptile sunning itself too early. any small thing slow to notice a shadow. The hunter freezes when the herd lifts its heads, then drifts forward again when they lower. Patience here is not calm. It is a held breath with teeth behind it. Look closely at the hands. Each one carries 5 fingers, tipped with curved claws, and that number matters more than it seems. The great meat-eaters that come long after this morning will hunt with only 3. This animal still grasps with a fuller, older hand a structure closer to reaching and holding than to the reduced tools of later predators. When it steadies itself against a fallen trunk, those 5 fingers spread and grip the wet bark like a wide, clawed palm laid flat. The mouth is the other half of the weapon. Inside those jaws sit rows of teeth curved backward toward the throat, their edges finely serrated like the blade of a fine saw. Teeth shaped this way are built for one motion. They let flesh slide in and never let it slide back out. A struggling animal that pulls against them only drives itself deeper onto the row. The Herrerasaurus does not need to chew. It needs to hold, and to keep holding while the fight goes out of whatever it has caught. Now the herd shifts, and a gap opens. Something small breaks from the fern line and runs for the water. The hunter is already moving. There is no long chase, only a short burst, a low lunge, the head snapping down and to the side. The jaws close, and here the anatomy does something you would never guess from the outside. Deep in the lower jaw along each side runs a flexible hinge, a joint set within the jawbone itself. As the prey thrashes, that hinge lets the lower jaw bow outward, then draw back in, closing the teeth tighter around the struggling body. The mouth grips the way a hand tightens on a rope that is being pulled. Every kick of the caught animal only helps the jaw find a firmer hold. The struggle is brief. The hunter plants both feet, drops its weight back over its hips, and lets the flexing jaw and the backward teeth do the work its size cannot. In the hip, hidden under muscle, is the one feature that quietly marks this creature, apart from most of the animals sharing its river. The socket where the thigh bone meets the pelvis is not a solid cup. It is an open hole, a window straight through the bone. That perforated hip socket is the plain, physical signature that separates a true dinosaur from the other reptiles around it. On this morning it means only one thing to the Herrerasaurus. It means a stance that lets it stand tall over its meal and swallow in the open, watching the mist while it feeds. Because feeding in the open is a risk here, and the hunter knows it. This is not a world that belongs to animals like this one. Listen past the dripping ferns and the fussing rhynchosaurs, and the soundscape tells you who truly rules the ground. There is a heavier tread out there. The floodplain is patrolled by crocodile-line reptiles, the pseudasuchians, and some of them dwarf this dinosaur completely. They are the large predators of this age, thick-limbed and armoured, built on a scale the Herrerasaurus will not match. When one of them moves through the brush, the smaller hunter lifts its head from its meal and goes still, reading the distance, ready to abandon the kill if the shape grows too large. That is the quiet truth of this morning. The Herrerasaurus is a competent killer and still only a minor figure in its own home. Around it the great niches are already filled, and filled by others. The bulk-bodied plant-eaters are dicynodonts and rhynchosaurs, not dinosaurs. The top predators wear the crocodile-line body plan, not this one. A creature like the one at the water's edge lives in the seams between larger lives, taking what the giants overlook, staying quick, staying wary, staying small enough to slip away. It is not alone in that seam. Share this floodplain a little longer and you would meet its neighbours. A slighter hunter, no bigger than a large dog, lightly built and fast, moves through the same ferns. Smaller still, a slender omnivore carries an odd mouth, blade-shaped teeth at the front and leaf-shaped teeth behind, a jaw that seems stitched together from 2 different animals. These are the early dinosaurs, already splitting into hunters and plant-eaters, and the uncertain diets in between. They are a young experiment running quietly in the margins, in the shadow of animals that have no reason yet to fear them. Wherever you are listening, on Spotify, on YouTube, or in your podcast app of choice, follow or subscribe and let the river keep running. By late morning the mist has burned off, and the light falls hard and dry across the badlands beyond the green corridor. This is the deep character of the age. The interior of the joined continent is mostly parched, a vast arid heart with no ice at either pole. The rivers and their fern-lined banks are narrow ribbons of life threaded through that dryness, and even those ribbons are not fixed. The climate here swings. For long stretches the land stays hard and cracked, then damper pulses arrive, and the floodplains swell and green, and the browsing herds spread wider. The Herrerasaurus lives inside that swing, following the water when it retreats, moving out again when the rains return. Through the heat of the day the hunting goes still. Nothing worth chasing moves in the open glare, and the hunter does not waste itself in the sun. It withdraws to the shade of the fern understory, where the ground stays cool and the light comes through green and broken. There it settles, folding down over its own long legs, tail curled along the flank. It is not asleep. The eyes stay half open, tracking the flicker of insects, the far-off shapes of the rhynchosaur herd drifting back toward the water. A predator this size does not fully relax in the open. Rest here is only a lower setting of the same wariness that carried it through the morning. The afternoon cools, shadows stretch across the banded clay, and the reds deepen toward brown while the ash-grey layers turn the colour of old smoke. The heavy footfalls of the larger reptiles come and go along the margins, and each time the resting hunter marks them and lets them pass. It has eaten. It has not been eaten. On this floodplain, for an animal of its kind, that is the whole measure of a good day. As the light goes long and low, the river takes on the chill again, and the cold begins its slow climb back up the shallows. The Herrerasaurus rises, stretches the stiffness from its shins, and drifts toward the cover of denser fern for the night. It is the same animal it was at dawn, no larger in the order of things, no closer to inheriting this ground. Its 5-fingered hands, its backward curving teeth, its flexing jaw, and its open-windowed hip make it a fine hunter of the margins and nothing more. The great weight of this world still rests with the giants and the crocodile cousins, and it will keep resting there for something near 30 million years to come. Nothing in one day at this water, however patient, could tilt that weight. No hunter walking this margin could shift an order that heavy from below. It would take the sky itself turning against that world to shift the balance, and the sky did turn. Not in a single afternoon, but across a stretch of time so long you could not have waited it out in one lifetime, or in 100 lifetimes stacked end to end. Picture the dry interior of Pangaea, roughly 234 million years ago. It is a hard country, red underfoot, baked pale along the ridgelines. For as long as anything living can remember, the rain has come rarely and left fast. Then it changes. The clouds gather over the interior and they do not leave. You're standing at the opening of the Carnian Pluvial episode. It ran for something close to 2 million years, a wet chapter torn into the middle of a mostly parched world. The arid pattern that had ruled Pangaea for ages simply reversed. Humid, monsoon-like air pushed inland, over red beds that had not seen standing water in generations. Rivers that ran a few weeks a year began to run for months, and the rain kept falling season after season until the land itself forgot how to be a desert. Hold that in your mind, because it matters. This was not a passing storm. If you had been born at the start of that wet interval and lived a full life beneath it, you would have died with the rain still coming down, and your grandchildren would have too. To the animals living through it, the change was invisible and total. The world was simply wet now, and it stayed wet, and that slow drowning of an old climate is where our story turns. You can still read that turn in the rock. In the pale mountains of northern Italy, in the layered stone of the Dolomites, geologists find a clear signal buried in the sediment. The dry limestones give way to darker, wetter deposits, then climb back toward dry again. It is the whole episode written in stone, the arid world going humid and then arid once more. And pressed into those same wet layers, something else appears in numbers that had not been there before. Footprints. small, three-toed, bird-like tracks, laid down by animals moving fast on two legs. Those tracks belong to early dinosaurs, and their sudden surge across the record is not coincidence. Something had come along and cracked the old order open. The trigger most likely came from the far side of the planet. A vast volcanic province called Wrangell was erupting, pouring lava and gas across what is now the western edge of North America. When that much rock melts and breathes out its buried carbon, the air changes. The whole atmosphere warms, the ocean loads with moisture, and the rain patterns that had held for ages break down. A wet Pangaea was the result, and a wet Pangaea was a killing ground for the animals built for drought. Watch who falls. Across the Carnian, several groups of dominant plant-eaters thin out and vanish. The stout, tusked, beaked dicynodonts that had cropped the dry floodplains for millions of years lose their footing. The bulky, barrel-bodied rhynchosaurs, those pig-snouted grazers that had been everywhere underfoot, dwindle toward nothing. These were the great herbivores of the Middle Triassic, the animals whose sheer numbers shaped every landscape, and one by one the climate pulls the ground out from under them. When the big grazers go, they leave more than empty space. They leave open jobs, every plant they had eaten, every patch of floodplain they had trampled, every predator that had fed on their young, all of it comes loose and waits for something new to take it up. In an ecosystem, that kind of vacancy does not stay empty for long, and the animals best placed to move into it were the small, quick, unremarkable ones that had been waiting on the margins the whole time. That is where you find the dinosaurs, not ruling anything yet but present, adaptable, and suddenly surrounded by opportunity. As the wet interval settled and then dried back out toward the end, their footprints multiply and their bones grow more common. New plant-eating lineages appear, new hunters spread. It is the first real pulse of dinosaur diversity, and it rides in on the back of a climate catastrophe that emptied the seats they would come to fill. Now, be careful here, because this is a place where honest scientists still argue. It is tempting to draw a straight line and say the wet climate made the dinosaurs. The truth is quieter than that. The Carnian gave them room, an opening where old competitors weakened and vanished. But it did not hand them the world. For all the new tracks in the Dolomites, dinosaurs were still a minor presence when the rain finally stopped. They had gained a foothold. They had not won. Because when the wet interval ended, the ones who rose highest were not the dinosaurs at all. They were the crocodile-line reptiles, the pseudosutians, the great armoured and long-legged cousins of today's crocodiles. They took the drying world and they took the largest bodies in it. For the next 30 million years they wore the crown that the dinosaurs would one day inherit. If you had walked those late Triassic floodplains and picked the animal most likely to rule the future, you would not have pointed at the small two-legged hunters. You would have pointed at their crocodile-line rivals, and you would have been wrong, but only because of what was coming. Let that sit as the open question, the one this whole long stretch of time keeps asking. Were the dinosaurs simply better, built to win from the start? Or were they lucky, small survivors who happened to be standing in the right place when the sky turned against everything larger than them? Hold on to that question. The answer is coming, and it is not the flattering one, because the sky was not finished. Roughly 201 million years ago, near the very end of the Triassic, it turned again, and this time it turned harder. You would not have seen it begin. The first signs were underground, and far away, along a seam in the heart of Pangaea, where the supercontinent was starting to tear itself in two. The land that would one day split into the Americas on one side and Africa and Europe on the other was pulling apart at its centre, and along that widening wound magma began to force its way up through the crust. This was the Central Atlantic Magmatic Province, one of the largest volcanic events the planet has ever known. When Pangaea rifted, it did not crack cleanly. It bled. Enormous volumes of molten rock pushed into the crust and spilled across the surface in pulse after pulse, over an area so vast the lava fields would end up scattered across 4 future continents. And with the lava came the gases, carbon dioxide and sulfur, breathed into the air in quantities the living world could not absorb. Here is a detail worth slowing down for. When geologists date these rocks with great precision, reading the slow radioactive clock locked inside crystals of zircon, the uranium and lead atoms give up a startling timeline. The magmatic activity was already underway roughly 100,000 years before the earliest known eruptions broke the surface. The wound was open and working long before it showed. The poison was building in the ground while the world above still looked ordinary. Animals feeding, breeding, dying of nothing unusual, with the catastrophe already ticking beneath their feet. Then it surfaced, and the end Triassic extinction became one of the 5 great die-offs in the history of complex life. More than half of all genera vanished. On land and in the sea, better than 1 in every 2 named groups of animals simply ended. The warming spiked. The oceans turned acidic and starved of oxygen. Reefs collapsed, and across the drying, cracking, gas-choked continents, the great ruling reptiles of the Triassic began to fall. Watch the crocodile line reptiles now, the pseudosuchians who had held the largest bodies, and the top predator roles for 30 million years. Watch them go down. Nearly every one of those lineages dies here. The armoured plant-eaters, the long-legged hunters, the whole magnificent radiation of crocodile cousins that had outclassed the dinosaurs for so long, almost all of it is erased in the span of the crisis. Only one narrow branch survives. The ancestors of the modern crocodiles holding on in the water and the shadows, a fraction of what their family had been. And the dinosaurs? Nearly all of their lineages come through. Sit with how strange that is. The group that had spent 30 million years losing, the small hunters kept to the margins, walk out the other side of the disaster nearly intact. The group that had been winning, crocodile line reptiles who owned every large body, are gutted almost to nothing. The extinction did not reward the dominant, it cleared them. And into the space they left, a space that had been closed to dinosaurs for their entire existence, the survivors finally spread. This is the door opening. What lies beyond it is roughly 136 million years in which dinosaurs will rule the land, growing into the largest animals ever to walk the earth, filling every role from sprinting hunter to 100-foot giant. All of it begins here, not with a triumph, but with a survival. So return to the question we left open. Superiority or luck? For a long time the story ran one way. The dinosaurs won, the reasoning went, because dinosaurs were simply better, faster, smarter, built on a superior body plan that was always going to sweep the older reptiles aside. It is a satisfying tale. It is also, by the best evidence we have, wrong. When paleontologists actually measured the 2 groups against each other through the Triassic, they found something humbling. The crocodile line reptiles were not falling behind. By some measures they were doing better than the dinosaurs, with roughly twice the range of body forms, thriving across more niches, evolving at least as fast. Right up to the edge of the extinction, the Cretaceans were not a fading dynasty waiting to be replaced. They were flourishing. If you had scored the contest the day before the volcanoes spoke, the crocodile line was winning, and then the sky decided it, not the animals. The extinction fell across both groups, and for reasons we still do not fully understand, it spared one branch of the family tree and shattered the other. The dinosaurs did not outcompete their rivals into oblivion. They outlived them through a catastrophe that neither could have foreseen or fought. The crown was not earned in battle. It was inherited from the dead. That is the harder, truer answer, and it is worth saying plainly because the flattering version has been repeated for so long. Survivorship, not superiority. Standing in the right place when the world broke, not being the better animal. The dinosaurs would go on to justify their inheritance across 100 million years of astonishing life. But the moment they received it was a moment of luck, drawn from the ruin of creatures that had beaten them at nearly every turn. Now let me show you one of the animals that walk through that open door. Come north and west to the red rock of what is now New Mexico, to a place called Ghost Ranch, and to a slender hunter named Coelophysis Bowery. Picture it alive. It stands about knee to waist high at the hip and stretches up to 9 or 10 feet from its narrow snout to the tip of its long tail. But most of that length is neck and tail. The body itself is light, hollow-boned, built like a whip. You could have lifted a grown one without much strain the way you might lift a large bird. It runs on 2 legs, quick and low, with a mouthful of small blade-edged teeth, a hunter of insects, of small reptiles, of anything it could outpace and pin. This is not a giant. This is a survivor, a lean early theropod living in the last breath of the Triassic, in fern-choked forests of conifer and cycad, along a river that flooded without warning. And at Ghost Ranch, that river did something almost unbelievable. It gathered Coelophysis by the thousand and buried them together. The quarry there, first opened in 1947, gave up the remains of more than 1,000 individual Coelophysis. 1,000, packed into roughly 30 cubic meters of rock, a volume you could nearly fit inside a modest room. It is one of the densest single-species graveyards ever pulled from the ground, a tangle of skeletons layered over and through one another, adults and juveniles pressed together in the stone. Read the bones, and you read the death. The skeletons lie articulated, still joined the way they were in life, overlapping in heaps. There are no bite marks, no gnawing from scavengers, no cracking or bleaching from long exposure to sun and air. Every clue points the same way. These animals were not picked apart over months on a dry plain. They were caught all at once and sealed away fast. The leading explanation is a flash flood, a wall of water tearing down that river system, sweeping up a crowd of Coelophysis and dropping them, drowned, into a single grave that hardened around them. We should be honest that no one watched it happen. The flood is an inference, the best reading of the physical evidence, and other ideas have been floated over the years: drought gatherings, poisoning, disease. From bones alone, you cannot rule every alternative out completely. But the sudden burial, the articulated skeletons, the absence of weathering, all of it fits a fast and violent flood far better than a slow accumulation. That is where the weight of the evidence sits. And there is one more thing about Coelophysis that you may have heard, and that you should now unlearn. For decades, this animal carried a dark reputation. Inside the rib cages of some adult skeletons, early researchers found small bones, the remains, they believed, of juvenile Coelophysis. The conclusion seemed obvious and grim. Here was a dinosaur that ate its own young, a cannibal preserved in the act. The claim spread into books and museums and films, and it hardened into something people simply knew about this creature. Then, in 2006, paleontologists went back and looked again, carefully, at those bones in the belly. And the story fell apart. The small skeletons inside the rib cages were not baby Coelophysis at all. They belonged to little crocodile-line reptiles, early crocodilomorphs, small enough to be swallowed and lodged where a last meal would sit. The cannibal was not a cannibal. It was simply a predator with a reptile in its gut, misread for the better part of a century. I tell you that not just to correct the record, but because of what it teaches about this whole long stretch of deep time. A claim can stand as settled fact for decades and still be wrong. The confident story is not always the true one, and the same caution that overturned the myth of the cannibal dinosaur is exactly the caution that overturned the myth of dinosaur superiority. In both cases, the flattering, dramatic version gave way, under harder looking, to something more careful and more strange. So here is where the small hunters stand. Coelophysis, quick and light in its river forest, is not a champion who conquered the world. It is a member of a group that spent its whole early existence in the shadow of larger, more successful animals, and then survived 2 climate catastrophes that its rivals did not. The Carnian rains weakened the old grazers and gave the dinosaurs their first real opening. The end Triassic volcanism gutted the crocodile line and handed the survivors an empty stage. Neither disaster was earned. Neither was deserved. They simply happened, and the dinosaurs were standing in the right place when they did. You can feel the weight of that if you slow down over it. For tens of millions of years, these animals were the understudies, small and marginal, easy to overlook. It took the sky turning against their world not once but twice to move them from the edge to the centre. And even then, on the far side of the second catastrophe, they did not arrive as conquerors. They arrived as the ones who were left, blinking into a world scraped nearly clean of everything that had kept them small. That world would never be a desert of possibility again. The largest niches lay open. The great rival dynasty was gone into the rock, and a lean hunter, no heavier than a big bird, stood at the head of a lineage that would grow over the ages to come into the most spectacular animals the land has ever held. But that growth belongs to another chapter, on the far side of the boundary, in a world just beginning to dry its eyes from the disaster. For a long time, you were taught to read that survival as a verdict. The dinosaurs endured, so the dinosaurs must have been better, faster on their feet, smarter, more efficient in the way they breathed and moved. It is a tidy idea, and for most of the last century it went almost unquestioned. Then paleontologists went back and measured it, patiently, and the tidy idea came apart in their hands. Think about what they actually compared, not simply who lived and who died. They looked at how much anatomical variety each group carried, how many ways of building a skull, a hip, a set of teeth. This spread of forms has a plain name, disparity, and it works like a measure of how much room a lineage was exploring at once. Through most of the Triassic, the crocodile line reptiles, the pseudoseuchians, carried roughly twice the disparity of the dinosaurs beside them, twice the range of body plans, twice the number of shapes worth trying. Picture the ground those animals shared. The dinosaurs were the lean, quick sideline. The pseudoseuchians were the main event. Some walked upright on long legs like the dinosaurs did. Some sprawled low and armoured, plated along the spine like living pavement. Some grew into the largest land predators of their day, jaws wide enough to close over a body the size of the small hunters you have been following. If you had walked that floodplain and tried to guess which branch would inherit the world, you would almost certainly have guessed wrong. Researchers also looked at evolutionary rate, how fast each group was throwing out new species, new experiments, new answers to the same old problems of eating and moving and staying alive. And here too the crocodile cousins kept pace. They were not a fading lineage limping toward an exit. They were diversifying, thriving, filling the big-bodied niches while the dinosaurs stayed small and marginal at the edges. Right up to the end of the Triassic, roughly 201 million years ago, the two branches were running neck and neck. By the numbers that survive in stone, neither one was winning, so hold that picture in your mind. Two lineages, balanced like a pair of stones resting on the two pans of a scale, nearly matched in weight. The beam level, or close to it, quivering in the smallest breath of air. Nothing about that balance points to one stone being finer than the other. It only takes a single tremor, from somewhere neither stone can see, to tip the whole thing and send one crashing down while the other rides up untouched. That tremor came from deep in the earth. As Pangaea began to pull apart, vast sheets of magma forced their way up through the crust, part of a volcanic province that opened along the seams of the breaking continent. The eruptions loaded the air with carbon dioxide and sulfur. The climate lurched. The oceans turned acidic and starved of oxygen. And when the dying was over, the scale had tipped hard. Almost every pseudoseuchian lineage was gone. Only the ancestors of modern crocodiles slipped through. Nearly every dinosaur lineage, by contrast, survived. Notice what that pattern does and does not tell you. It does not tell you the dinosaurs were built to win. If superiority had decided things, you would expect the losers to have been fading already, outcompeted and shrinking, before the volcanoes ever spoke. Instead, the losers were flourishing, They were cut down at the height of their success, and the survivors happened to be standing on the right pan of the scale when it tipped. That is the case for luck. Not luck as magic, but luck as the honest word for an outcome that turned on an accident of timing rather than any contest the animals themselves could have won. You should be careful here, because this is a live discussion and not a closed one. Chance and advantage are not perfect opposites, and some traits that looked like neutral quirks in the Triassic may have paid off in the aftermath. Perhaps something in how dinosaurs grew, or breathed, or raised their young helped a few of them scrape through the bottleneck. That remains genuinely open. What the comparative studies did settle is narrower and more useful. They dismantled the old certainty. You can no longer say the dinosaurs marched to dominance because they were the better design. The evidence for that verdict simply is not there. This is a good moment to say quietly that if these long walks through deep time keep you company, you can follow or subscribe wherever you are listening, on Spotify, on YouTube, or in your podcast app of choice. Now, back to the aftermath, and to a second story that was told with the same false confidence for even longer. It begins in the red rock of Ghost Ranch, New Mexico, in the year 1947. A team from the American Museum of Natural History, led by the paleontologist Edwin Kolber, opened a quarry in the Chinle Formation and found something staggering. Bones everywhere. Not scattered, but packed together in a dense tangle of skeletons, one animal laid over another. Before they were done, they had pulled the remains of more than 1,000 individuals of a single slender predator from roughly 30 cubic meters of stone. It is one of the richest single-species graveyards of its kind ever uncovered. The animal was Coelophysis, a lightly built hunter up to about 10 feet long, alive near the very end of the Triassic close to 200 million years ago. Among all those interlocked skeletons, a few seem to hold a darker secret. Inside the rib cages of certain adults, right where the belly would have been, lay smaller bones. Delicate ones. To the eyes that first studied them, those little bones looked like the remains of young Coelophysis swallowed whole. The reading was almost irresistible. Here was a predator that ate its own kind, its last meal fossilized inside its own chest. Cannibalism written directly into the rock. That interpretation took hold and would not let go. It appeared in books, in museum labels, in the confident narration of documentaries. For decades you could recite it as a fact about this animal. The cannibal of Ghost Ranch. It had everything a memorable claim needs: a grisly image, a famous quarry, and just enough visible evidence to seem beyond doubt. Then, in the year 2006, other paleontologists at the same museum went back to those specimens and looked again, closely, at the little bones inside the ribs. And the bones did not belong to baby Coelophysis at all. They belonged to small crocodile-line reptiles, early crocodilomorphs, animals from an entirely different branch of the Archosaur tree. What had been read as a swallowed infant of the same species was, in truth, ordinary prey. Coelophysis had eaten a small relative of the crocodiles and died before digesting it. That is a meal, not a murder of its own kind. This matters as more than a corrected caption. It is why you should treat the cannibalism claim not as merely uncertain, but as genuinely overturned. Sometimes an old idea fades into a maybe, and honesty means holding it loosely. This is not one of those cases. The evidence that once seemed to prove cannibalism was re-examined and found to point somewhere else entirely. If you meet the cannibal story now, in an older film or a dated display, you are looking at a claim that science has already set aside. The most striking single fact about Coelophysis for half a century turned out to rest on a misread pair of bones, and there is a second, humbler caution folded into the same quarry about how all those animals came to die together. The leading explanation, supported by how the fossils lie, is a flash flood. The skeletons are articulated and overlapping, tumbled but whole, with little sign of scavenging or slow weathering on the bone. That pattern reads as sudden burial. A river in an arid land, swollen without warning, sweeping bodies into a low place, and sealing them under sediment fast enough to keep them intact. It is the kind of death this landscape was built to deliver, a dry country that floods hard when it finally rains. But you should hold even that leading answer with an open hand. Over the years, others have proposed different killers, a poisoned waterhole, a spreading sickness. The trouble is that a bone bed cannot be interrogated the way a fresh scene can. The evidence is circumstantial, read backward from arrangement and chemistry and the shape of the rock. Flash flooding fits that evidence best, and it is where the weight of the reasoning sits today. Yet poisoning and disease cannot be fully ruled out from a record this old and this indirect. The quarry shows you with great clarity that 1,000 animals died close together and were buried quickly. Exactly what struck them down, it does not quite say. Both stories teach you the same discipline. The confident verdict, the memorable image, the fact everyone repeats, each can rest on a reading that does not survive a second harder look. The dinosaurs were not obviously the better design. The cannibal of Ghost Ranch was eating something else. What endures is not the tidy conclusion but the careful measurement underneath it, and the willingness to say plainly where the evidence still runs out. That is the true shape of the record these small hunters left behind. Not a triumph earned, but a survival granted, by forces indifferent to which lineage deserved to walk out of the wreckage. By the time the dust and ash had settled, the small hunters from the margins had inherited a broken world at last. By the time the dust and ash had settled, the small hunters from the margins had inherited a broken world at last. By the time the dust and ash had settled, the small hunters from the margins had inherited a broken world at last. Hold that thought a moment, and let the camera begin to rise. The floodplain falls away beneath you. The ferns, the red and grey banded clay, the quick two-legged shapes at the water's edge, all shrink into a single green thread, winding through a dry continent. Keep rising. You're looking down now on Pangaea entire, one vast landmass with no ocean to break it. The humid coasts blur into the parched interior. Deserts stretch for 1,000 miles without a river. From up here the whole crowded drama of the Triassic becomes a faint stir across the parchment of the land. Higher still, and the continent draws in. It becomes a shape you could cover with your palm, then smaller, a coin of pale rock turning slowly in the dark, and around that coin the years themselves begin to close. Watch them fold shut like a book. The last page is 201 million years ago, the moment the field was finally cleared. Turn back through it, and the pages run to 252 million years ago, to the fire that emptied the world in the first place. 51 million years, laid flat between two covers. Let it settle closed. Let me gather the thread for you one last time, gently, before we let it rest. It began with an ending. The worst ending Earth has ever recorded. The eruptions of the Siberian traps poisoned the air and the seas, and up to 9 in every 10 marine species vanished. The land emptied almost as thoroughly. What survived crept through a world stripped down to bare bone. Into that silence walked a squat, unglamorous survivor. Lystrosaurus, a beaked, pig-sized plant-eater, no larger than a big dog. It was not fierce, it was not fast, but it endured and it multiplied, until in some places it made up as much as 95 in every 100 animals on the ground. Whole herds of a single kind, moving across empty floodplains under an anxious sun. A living monument to how few had made it through. Recovery came, but slowly. Far more slowly than the counting of species suggests. It took tens of millions of years for the web of life to knit itself back into something rich and stable. And it was during that long, patient rebuilding, not after it, that the first dinosaurs appeared. They did not arrive as kings. They arrived as afterthoughts. Small, rare, easy to overlook. Nyasasaurus, known from little more than an arm bone and a few vertebrae, hints that the lineage reached back perhaps 243 million years, further than anyone once believed. Yet for all that antiquity, these early dinosaurs stayed on the edges of the picture. You saw them in the Valley of the Moon, Eoraptor, barely 3 feet long and lighter than a small dog, Herrerasaurus, a lean hunter with an open hip socket that marked it as truly one of their own, yet still carrying an old 5-fingered hand, Eodromaeus, quick and slight. They shared their ground with rhynchosaurs and with the crocodile-line reptiles, the crustaceans, who were larger, more varied, and far more numerous. For more than 30 million years, the big roles all belonged to someone else. If you had stood on that floodplain and been asked to name the animals who would inherit the earth, you would not have chosen the dinosaurs. Nobody watching would have. The evidence points the other way. The crocodile-line reptiles were doing at least as well, filling more shapes, holding more ground, right up to the end. Then came the 2 catastrophes that changed the outcome. The first was a long shift in the weather. The Carnian Pluvial episode, around 234 million years ago, when the dry interior turned humid for a spell, then dried again. Old herbivore communities faltered, and dinosaurs quietly widened their footing. The second was sharper and far crueler. Around 201 million years ago, as Pangaea itself began to split, immense volcanism tore through the end of the Triassic. More than half of all genera on land and sea were lost, and here is the honest heart of it. When the smoke thinned, almost every crocodile-line lineage was gone, save for the ancestors of today's crocodiles. Almost every dinosaur lineage survived. The animals who had spent 30 million years losing were suddenly the ones still standing. You should hear that plainly. Their inheritance was not a reward for being better. The record does not show dinosaurs outcompeting their rivals in some slow, deserved victory. It shows them enduring a lottery that fell this time in their favour. Survivorship, not triumph. The ground was handed to them because so much else had let go of it. That is how Coelophysis came to walk a wide-open world at Ghost Ranch, slender and swift, with nothing large left to crowd it. More than 1,000 of them lie together in that quarry, gathered by a single flood at the threshold of the age that would follow. The first true morning of the dinosaurs began not with a roar of conquest, but in the quiet after a disaster nobody chose. There is a strange comfort in that. The world does not always reward the strong or the certain. Sometimes it simply keeps whoever happened to still be there when the shaking stopped. The small, the marginal, the overlooked, the ones who inherited the ground by outlasting it. So let the coin of Pangaea keep turning in the dark, slow and untroubled. The volcanoes are cold now. The floodplains are dry stone banded red and grey and white, waiting patiently to be read. Every one of those creatures lived a whole life you will never fully see, and then let go, and became the quiet rock beneath later worlds. Let the last of it fade away into the deep quiet where all these vanished animals rest. And now let the day you have carried fade too. Take one slow, easy, deep breath, and let your shoulders come down from wherever they have been holding. There is nothing left tonight that needs your watching. The story is told, the world is folded shut, and it will keep without you. You have travelled a long way in the dark, across an emptied earth and its lonely survivor, across small hunters on the margins, across 2 catastrophes and a field finally cleared. You do not need to hold any of it now. It has waited 200 million years already. It will still be here. Let the camera drift higher, past the turning coin, until even that is only one faint point among many, and the dark grows soft and wide and kind. Let your breath go slow. Let the weight of the day settle out of you like fine sediment coming to rest on a still riverbed. Everything down there is at peace. The ferns bend in a wind no one hears. The rivers run to seas that have long since dried. The small survivors sleep in stone, safe now, finished with their long work of enduring. And you can be finished too, just for tonight. Rest easy. The ancient world will keep turning quietly while you sleep, patient as it has always been. There is nothing to solve and nowhere to be. Only the slow dark and your own steady breathing, and the deep time closing gently over all of it like water. Sleep well tonight, traveller. Good night.